Yeah, thank you very much, Kazba. This is Itula Secondary School, Obongi District, and it's a school briefly that is hosting more of refugees, international, refugees from South Sudan. And we are delighted today to have a seminar here for A-level with you. So let's start the seminar with a word of prayer. In the name of the Father, and the Son, and the Holy Spirit. Father, Lord in heaven, we want to thank you for the gift of life, for this meeting today, that we are going to share knowledge from different participants across Uganda. Father, Lord, we commit this day unto your hands, that, Lord, may it be a success. Issues of network challenges, King of Glory, that may hinder some of our colleagues to join. Father, may it not be a problem. Father, thank you for the facilitators of today and the children that are going to share knowledge. Father, Lord, grant them knowledge and give them enough confidence in the presentations that they are going to have today. Father, we ask and believe that it shall be a success. Forever I believe and trust. In Jesus' name, Lord, I pray. Amen.
Thank you so much, Itula Secondary School, for the word of prayer. Good morning once again, and we would like to welcome all the schools that are joining in from the different parts of the country. You are most welcome, and we would like also to welcome dear students. Thank you so much for joining this session, and we pray that everything goes on well as planned. Our agenda will run as follows. We shall have a few introductions, and then we do expect that we shall have some representative from the Ministry of Education, Mr. Ronald. He will be joining us very soon, and he will officially open up the session. But in a special way, would like to welcome you all. Thank you so much for joining. Let's ensure that our neighboring areas, there is no noise such that we can be able to settle in very well. In case there is any question you may have, you can post it in the chat, but also you may raise your hand during the discussion. So we shall be able to support you and to ensure that everyone achieves something before we leave our session today. But we are very happy to have you, and thank you so much for being with us for our session today. As we start this session, we are going to first share. I know the representative from the ministry who will be joining us to officially open, but as it comes, I would like to ask all the schools that would like to present and those that have already prepared to rename themselves to put presenter, such that we can be able to choose you and give you the rights. Dear students, we know very well that the paper we are going to be dealing with is we are going to be dealing with mathematics, of which mathematics has mainly two papers that you have been doing uh, in your exams. However, I want to throw some light on the key sections for each of the papers that we do. We know very well that when it comes to pure mathematics, our paper one, these are the major topics that you need to know. One of them is algebra, and when you are preparing yourself for this paper, please have it in mind that in section A, you'll expect two numbers, but also in section B, expect two numbers concerning algebra. Then we have analysis. Also, we shall have 3 and 3. Trigonometry, you'll have 1 and 1. Vectors, you'll have 1 and 1. And then 1 in geometry and 1 in section B for geometry. What does it mean? That when you are preparing, please make sure that there are some sections you are well conversant with. Take an example. In order for you to be able to pass with an A, or for you to be able to get a distinction in this paper, it will require you to have at least 6 questions passed in section A. Now, when you multiply 6 questions times the mark for each of the questions, it means that you are going to be on a good advantage. And how can you determine that? You need to look at those sections that you feel you must be well conversant with. Let me say one of the sections, dear students, that we need to be very careful. Sections like algebra, analysis, trigonometry, at least you must be very good at those because these ones cut across both papers. The same thing happens when it comes to section B. Make sure that in section B, for each of these parts, make sure that, because remember for them, these items in section B are optional. So look out for those particular ones where you can maximize and choose always those questions you feel are easy to be attempted. Then when it comes to paper 2. Still, paper 2 has mainly these sections or these topics that are being said. But the major ones we have numerical analysis, which has 2 questions in section A and 2 questions in section B. And when we talk about numerical analysis, there are things that you need to expect, things like errors, things like interpolation and extrapolation, the trapezium rule, roots of equation, Newton-Raphson methods, and then the flow charts. Now, if you are preparing yourself, this is the section. These are the numbers. At least you must be able to maximize that. I have my 2 numbers in section A. I have my 2 numbers in section B. If you maximize very well in numerical analysis in section A and section B, it means that there is then no way you are going to fail to obtain an A. Then come in statistics and probability. Now, when it comes to statistics, there are some topics you need to look out for, or there are topics. One is what you call the descriptive statistics, where you calculate your mean, mode, median, and the rest, histograms, ogive. Then you have correlation as well in that same part. Then you'll have scatter diagrams, and then you'll have what you call index numbers. Now, when it comes to statistics, we have in statistics, you have one in section A, you have one in section B. So you expect either it will be about descriptive statistics, it will be about correlation, it will be about scatter diagram or index numbers. That means that now if you are preparing, be sure that you have your marks you have your 5 in section A and you have your 12 in section B. So you prepare well knowing that I have descriptive statistics, I have correlation, I have scatter diagram, and have index numbers. One of them must appear, and you'll find that in section, in case in section A, you find that here they have put index number. You'll find that in section B, they can put what you call descriptive statistics. If you find that in section A, they are putting something of descriptive statistics, you'll find that this side around, they are putting something maybe of scatter diagrams. So you can check out even last year, I think, when you check out last year's paper. In section A, we had index numbers. In section B, we had the descriptive statistics. So when you are preparing, these are the marks you must carry along with you as you enter the paper. Then when it comes to the section of probability, now, probability, we shall have 2 questions in section A, 2 questions in section what? In section B. But under probability here, you need to know that you'll have things like probability theory, random variables, binomial, normal approximations, normal distributions, estimations. So those are the things you should expect. So you expect that you'll have 2 questions in section A, you have 2 questions in section B. Now, it comes to the mechanics. Now, when it comes to the part of mechanics, mechanics has mainly the 3 branches, the static, the dynamic, and then the kinematics. But I do understand that in some of our schools, not all these sections are being covered because sometimes students who are not offering physics, sometimes they find it hard to do numbers concerning mechanics. But there are some numbers or there are some sections at least we must be able to do or to try. Now, when it comes to the first section, what we call the kinematics. Kinematics, that is where you find things of distance, time, velocity, speed, where we find uniform motion. Where you find uniform motion. they are related to those things you are doing in O level, whereby you have a distance, time graph, and the rest of that. That is uniform motion. That's why you're going to find things of vertical motion, horizontal motion. That's why you find projectiles. So when you are preparing, expect that any of these ones is appearing. Either it is, you'll have one in section A and one in section B. Now, when it comes to the thing of static mechanics, that's where you find things of resultant force, things of moments, coronal forces, center of gravity, and the rest of that. That is now what we call the static mechanics. Then we have the other section we call the dynamic mechanics. Under the dynamic mechanics, here we are mainly concerned with the Newton's laws of motion. So this is where you find the Newton's laws of motion. This is where you are going to find connected particles. This is where you find work, energy, and power. This is where you find things of momentum, impulses, simple harmonic motion, circular motion. So that is that section. So still in that section, you'll find that one number appears in section A and one number appears in section B. So now you need to know which area am I going to be very strong in. We can be strong in all areas, but now it depends on the background that you do have. Therefore, I wanted to first bring this knowledge such that as we dig deep into the seminar, you know very well which areas are going to be of concern and which areas do you need to know as you are preparing yourself. So, allow me now to stop the sharing, and then I'm going to display the questions that we are going to discuss. Now, these are the questions that schools received, and we hope that everyone on the call has received these questions, but we shall share in case you have not yet received the questions. But still, when you look at the front page, we were able to summarize for you the different topics and what you should be able to expect in those papers. So when you look at algebra, these are the questions that we are going to be discussing, and we are going to discuss both paper 1 and paper 2, and we shall expect by the end of the day, when each one of you has picked something, or when you have had a change in the mindset and the way you take on mathematics. Allow me at this juncture to welcome the Principal Education Officer from the Ministry of Education, and I would like to invite him to officially open the session, but also to give us his remarks. Mr. Ronald, you are most welcome.
Thank you, Mr. Kaziba. Are you hearing me well?
Yes, Mr. Ronald, you are clear.
Okay. Good morning, students and teachers and everyone who is joining us this morning. I'm happy to be here. My name is Ronald Dungu. I'm a Principal Education Officer in the Ministry of Education and Sports, and I'm happy to be following this program. I thank you, Mr. Kaziba, and your team for organizing us and bringing us together this morning. I would like to welcome the students and teachers who are joining this morning, and to thank you for choosing to collaborate with each other and not to compete. We are here to close the learning gap, and it is very important that we all learn together so that we grow this nation together. So for the schools who are joining, thank you for accepting to join. I bring you greetings from my colleagues at the Ministry of Education, and we are happy that the schools are talking to each other. There is an effort in the Ministry of Education to equip schools with ICT equipment. Some schools have already received a laptop, a projector, and a screen to help them in the teaching and learning process. And this equipment can be used to connect us. The rest of the schools that have not yet received will be receiving this equipment, and let us use this equipment to help us collaborate and learn together. So I would like to encourage all those who are coming to discuss to please prepare well, be on point, and also be patient with our questions because we will ask quite a number of questions to try and understand you. And for the audience, also, I would like to appeal to you to listen in so that you do not ask a question that has already been asked. I know at times these seminars will go up to late in the afternoon, but I hope the schools will arrange for your lunch such that in between you can have lunch without getting interrupted until when we have everyone discuss. But I also know that our friends from the SDA faith may not be joining us on Saturday, and we try to come back here on Sunday at 2 p.m. to try and cover those. So whoever we don't have discussed today, there is an opportunity for you to discuss tomorrow, but also an opportunity for you to learn more tomorrow. With those few remarks, I want to wish you a good day, and I declare this seminar open. Thank you.
Thank you so much, Mr. Ronald. And I would like at this point to invite to ask Kashen Secondary School to prepare. You are going to be our first school to discuss. Then I will also ask Itula to prepare. Itula, also kindly prepare. You are going to be the second. And then I would also request that all schools that have prepared the presentations kindly rename yourself such that I can be able to spot you out during the discussion. Okay, so I would like to ask Kashin Secondary School to kindly have your microphone opened and then your camera on such that you can lead us into the discussion. Then schools that have prepared, you can as well put in the chat such that we can be able to spot you. But also we are going to request teachers that have joined in for more support in the chat in case there is any question. But also we are requesting you to take photos of your students that are seated in the main hall of the school watching this seminar and participating. Take some photos and then you can share with us such that we can be able to include such photos in our report. Kashen Secondary School. Kindly unmute.
Yes, good morning, Mr. Kaziva.
Yes, good morning to you.
Yeah, this is Kashen Secondary School. And unfortunately, the students have gone for the party, but the presenter is here ready to present to you.
Okay.
All right.
Okay, I will request also Palabo Secondary to prepare. I know you are getting ready. Okay.
So as Kashen Secondary School, we are presenting the curve sketching from the topic algebra.
Question, we are not seeing the number.
So is my screen visible to all of us?
Okay.
So I'm going to use a piece of paper.
Mm.
So this is the number we are presenting, which is saying that sketch the curve y equal to 2x plus 2, then into x minus 2 out of 2x plus 5. So whenever we have this curve and we have sketch, we can begin by finding the turning points, whereby from here we can first realize that this is a difference of two squares. So we can write this as x squared minus 4 out of 2x plus 5. So we can cross multiply so that we have 2xy plus 5y, and this is equal to 2x squared minus 8. So when I make a quadratic equation in terms of x, I will have 2x squared minus 2xy plus minus 5. So this is here, this is coming this side. So minus 5y minus 8. So this is 2x squared minus 2y, and this is x minus 5y minus 8, and this is equal to 0. So I know that b squared minus 4ac has to be greater than 0. So my b is minus 2y. So this is squared minus 4a. My a is
Question
4.
in secondary?
Yes, sir.
Yes. In the denominator, it is 2x minus 5.
It is 2x minus 5.
Yes.
Okay. Thank you for clarification. So it is y equal to 2 into x plus 2, then x minus 2 out of 2x minus 5. So it is like this.
Yes, that is okay.
Okay, sir. So we cross multiply, we have 2xy minus 5y, and this is equal to 2 into the difference of two squares, which is x squared minus 4. So this is 2xy minus 5y. This is equal to x squared minus 8. So this is 2x squared minus 2yx. So when this goes this side, I have plus 5y minus 8, and this is equal to 0. So I will have my b squared minus 4ac, which should be greater than 0. So my b is negative 2y squared minus 4a is 2. My c is 5y minus 8, and this should be greater than 0. So 4y squared minus 8 into 5y minus 8, this should be greater than 0. So my 4y squared minus 40y plus 64 should be greater than 0. So this is a quadratic equation in terms of y. And if I put this on the calculator, I'm going to have quadratic equation in terms of degree 2. I have 4 minus 40 and then 64. So I'm having y minus 8 into y minus 2, and this should be greater than 0. So for boundary lines, since I have inequalities, so boundary lines, I have y equal to 8 and y equal to 2. So I go for the table whereby I will have y less than the least value, 2 less than y less 8, and then y greater than 8. So I can use this one here. So I have 4y squared minus 40y plus 64. So when I put this formula on the calculator, I'm going to put 4y squared minus 40y plus 64. I solve.
Oh.
Less
Kashan,
than 2.
can you bring the calculator such that people can see how you are putting it? Okay.
So let me first reset. So I started by putting this one here, this formula, which is 4y squared minus 40y then plus 64. I solve. So less than 2, I'm putting a 0, and this is giving me less than 2, putting a 0, 4y squared minus 40y. Now here it is plus. It's a plus, sorry. So I solve. Less than 2, I'm putting a 0, and this is giving me positive. I solve between 2 and 8. I can use, let's say, 5, and this is giving me a negative greater than 8. I'm using maybe 10, and this is giving me a positive value. And meaning that the curve lies in the range y less than 2, and then the range y greater than 8. So these are my turning points. I check when y is equal to maybe 8. I will come and substitute here. So this implies my 8 will equal to 2 into x squared minus 4. But this is out of 2x minus 5. So when I cross multiply, I will have 16x minus 40, and this is equal to 2x squared minus 8. So this is 2x squared minus 16x. So when this goes this side, I'll have 40 minus 8, which is plus 32. And this is equal to 0. So I come on the calculator, I press equations of degree 2. I put my equation here, which is now
Question? Okay, as Kashan gets back, yes. So the rest of the schools we can continue.
2.
Okay. Okay.
Hello? Hello, teacher Kazil.
Yes, the picture is not so clear now.
Is it now fine?
Okay, bit better.
All right. So we are going to check when y is equal to 2. It implies 2 is equal to 2 into x squared minus 4 out of 2x minus 5. So when I cross multiply, I will have 2 into 2x minus 5. And this is equal to 2x squared minus 8. So this is 4x minus 10. And this is equal to 2x squared minus 8. So my 2x squared minus 4x. So this is going this side. So I'll have 10 minus 8, which is plus 2. And this is equal to 0. So I still put this quadratic equation on the calculator. So I will put 2 minus 4, 2. Still it is giving me a repeated value. So meaning that I have x minus 1 squared, and this is equal to 0. So my x is equal to 1, meaning that the other turning point is 1 and then 2. So from the turning points, let me put this aside. From the turning points, I can now look for maybe the intercepts. So this is out of 2x minus 5. So when x is a 0, this is a 0. So I'll have y equal to 2 into minus 4 out of minus 5. So my y is equal to minus 8 out of minus 5. So I can reset this calculator here. So I'll have 8 divided by 5, which gives me 1.6. So my y is equal to 1.6. So I have one of the intercepts as 0 and then 1.6. Then I also check when y is equal to 0. It means 0 will equal to 2 into x squared minus 4. And this is out of 2x minus 5. So this implies x squared is equal to 4 and x is equal to plus or minus 2. Meaning that the other intercepts are negative 2, 0, and then 2, 0. Then plus the other one, which is 0, 1.6. So these ones are the intercepts. So from the intercepts, I can find the empty sections of the curve. Empty sections. For the empty sections, I will equate the numerator to 0 and also the denominator to 0. So my curve is y equal to 2 into x plus 2 into x minus 2, and the whole of this and the whole of this is out of 2x minus 5. So when I equate the numerator to 0, I will have x equal to 2. I will have x equal to minus 2. When I equate the denominator to 0, I will have x equal to 5 out of 2, which is the same as 2.5. So for the empty sections, I will have x less than the rest value, which is minus 2. I have minus 2 less x less 2. I have 2 less x less 2.5. Then I have x greater than 2.5. Then here I will put this y. So I will use the calculator and put the whole of this one here. So I will open the bracket 2 times. Opening, I will have 2 into x plus 2 into x multiplied by
Let's give them time. Okay.
I'm back. So this is 2x minus 5. I can now solve. So I'll put a value which is less than minus 2. So take an example of minus 5. This is giving me negative. I again solve. I put the value between negative 2 and 2, say a 0. So if I put a 0, this is giving me positive. I put a value between 2 and 2.5, say 2.1. So I solve 2.1. This is giving me negative. Then greater than 2.5, I put a value maybe 6. And this is giving me a positive. So I have the intercepts, I have the empty sections, I have the turning points. I can maybe find the asymptotes. So for the asymptotes, since this curve, like you see the curve here, the numerator is greater than the degree of the denominator. So I have to first use wrong division because this is an improper fraction. So I divide the numerator by the denominator for me to find one of the asymptotes. But before that, I can say that x, no, y is undefined when, so y is undefined when the denominator is equal to 0. So when 2x minus 5 is equal to 0. So x equal to 2.5 is my vertical asymptote. Then when I get 2, when I open the bracket, I will have 2x squared minus 8. I divide this by 2x minus 5. So when this divides here, we'll have x times 2x is 2x squared. X times negative 5 is minus 5x. And this gives me negative 2. This and this, they cancel. I have 5x minus 8. So I divide here. I will have add 2.5. So that 2.5 times 2 is 5x minus 2.5 times 5. 2.5 times 5. It is 12.5. 12.5. I subtract. So I will have 12.5 minus 8. 12.5 minus 8. It gives me 4.5. So now it means that my 2 into x squared minus 4 is equal to 2x minus 5 into x plus 2.5 then plus the remainder. But this is divided by 2x minus 5, 2x minus 5, and then 2x minus 5. So this implies that 2x squared minus 4 out of 2x minus 5 is equal to 4.5 out of 2x minus 5 plus x plus 2.5. So now as x tends positive or negative infinity, this will tend to 0. And this one, which is y, the whole of this is y, will tend to this other line here, 2.5. Meaning that this curve has a slanting asymptote, which is the equation of the curve, and y equal to x plus 2.5 will be our equation of the slanting
slanting asymptote. So I can find points to plot when x is 0, y will be 2.5, and I'll have 0, 2.5. Then also when y is 0, x is equal to negative 2.5. So I'll have negative 2.5.
Kashenyi?
Yes, sir.
Yes, I kindly request you to project more on your voice such that you are very clear, people can clearly hear you.
All right. So I'll have negative 2.50. So meaning I'll plot this point and this one for the slanting asymptote. So since I have the intercepts, I have the asymptotes, I have the turning points, I have the empty sections, those can be enough for me to plot this curve. So I can now proceed to plotting the curve. So I will have sketch the curve whereby this is the x and this is my y. I will begin with where the curve doesn't lie or the turning points. So from this table here, which we began with, we have that the curve does not lie between 2 and 8. So I can first plot those two. If this is my y equal to 2, and then y equal to so since we are in this region, there is no curve here by 2 up maximum. Then it's other for 8. If this so if this is 2, maybe 3, and then 4. So I'll have 4, 8, meaning there is a minimum turning point at this level. Then I can now plot the asymptotes. For the asymptotes, I had x equal to 2.5, x equal to 2.5, 2.5 is around here, meaning I have my vertical asymptote, and this is x equal to 2.5. I have the slanting asymptote, which has these values here, 0, 2.5. So 0 on the x-axis, and then 2.5 on the y-axis, meaning it is somewhere there. And then negative 2.5, if this is 1, 2, 3. So 2.5 is somewhere there. So I will join these two.
So if this is coming this way, and this is also coming this other way, so this is my y equal to x plus 2.5. So I've put the turning points, I've put the asymptotes. I can now check for the empty sections, see the behavior of the curve. So the empty sections are here. I have that less than -2, the curve is negative. So -2, these ones are negatives. That in this region, the curve is negative, but then there are intercepts. For the intercepts, we have -2, 0. So the curve passes at this point. We have 2, 0. So the curve also passes at this point. I also have 0, 1.6. 0, 1.6 is somewhere there. So meaning that this curve comes like this. So here where it cuts, it is 1.6. This is my 0. So it comes and turns at this level. So in the empty sections, we have that x less than 2, the curve is negative. So meaning this side, the curve is coming this side, and since this is a asymptote, it will not pass, so it will come like this. Since this is also an asymptote, and we are seeing that between -2 and 2, the curve is positive. So between -2 and 2, the curve is up, like we are seeing. Then from 2 to 2.5, the curve is negative. So it is coming down to 2.5. So it will come and it will not bypass this asymptote. And then between 2.5 So since this is a turn point and this is an asymptote, so the curve will pass through this as this in that and hello, yes, teacher Kaziba.
Okay. Your camera is off.
I can put it back.
Okay. Okay. Thank you so much. Let me hope everyone can be able to see the graph. We are going to take on some questions. In case you have a question, kindly raise up your hand. Those who may have some questions on curve sketching, raise up your hand and then you can ask. Kashan, I'm going to request you to put for us from the first paper, second paper, and third paper, such that people can be able to see. Yes, Lino, unmute.
Yeah, good morning, members.
Good morning.
By names, I'm Mtenyi Ibra from Mokoma Secondary School. The thing which I'm inquiring is like the one of empty section. Is it the same as critical values? And also the another thing is, can I be able to plot that graph without finding the turning point? Because I saw the presenter plotting without finding the turning point and also the nature of the curve. Thank you.
Okay, thank you. Yes, Kashin?
Hello.
Yes, Kashin?
So he was asking that I plotted without finding the nature of the curves of the turning points.
Yes.
Yeah, from here, from this table where I was finding where the curve lies and where it does not lie, I was able to determine that less than y less than 2, the curve will be positive. Between 2 and 8, the curve will be negative, and y greater than 8, the curve will be positive. So this table here can give me a rough sketch of how the curve will be. So when I come to the real plotting of the curve, I will first put those two, like you're seeing y equal to 2, and then y equal to 8. Since on this table, I got that the curve will be negative, meaning there is no curve between 2 and 8. So I can just come and shade this region, 2 and 8, because there will not be any curve. Then I have the turning points at 4, 8, and then 1, 2. So I also come and mark them. This is my 4, 8, and this is my 1, 2. So since I have those two turning points, I know at these points the curve will be turning. And since the curve will be turning, it cannot turn towards this area where there is no curve. So they will be turning towards where the curve will be. So I cannot turn this one facing down.
Oh, you
It can't
thinking?
be maximum. And neither this can be a minimum. So I will turn this one going where the curve will be and where this curve will be. And that will give me a rough sketch of how the curve will look like. Hope he is answered.
Okay, thank you. Itula?
Yes, good morning, everyone. My name is Jansuk Philip, a student from Mitula SS, and my concern is going to be where I started by equating b squared to be greater than 0. For me, I'm saying it's supposed to be, is it not supposed to be b squared is greater or equal to 0? And secondly, where he was plotting the asymptote, for me, I was saying that it's supposed to be, is it not supposed to be in a dotted line? Because I'm seeing him drawing also a straight line. So briefly, that is what I need more clarification about. Thank you.
Yeah, yes, Teacher Kaziba. If possible, you can maybe clarify on that whether if someone uses a complete line here for the asymptotes, whether is penalized or not.
Now, for the asymptotes, since our curve does not touch them, but it just reaches them, so to show that it does not need to touch them or it is not part of the solution, it is recommended to use the dotted line.
All right. Then he was also asking here where the b squared minus 4ac, that whether it is greater than 0 or greater or equal to 0.
Okay, can you first give him what you think before I come in?
The b squared minus 4ac. It should be greater or equal to 0.
Yes, that is right. For real values, it will be greater than or equal to 0.
So this should be greater or equal to 0. All right.
Okay, thank you. Okay, yeah. So when we are finding for real values, our b squared minus 4ac is greater than or equal to 0. But when we are dealing with this particular item, the major 4 areas, or I can say 5 of them, I'm going to share just my screen briefly. The major areas of concern or the major areas that we need always to look out for, these are the areas. One, being able to find the x and then the y intercepts. So those, then two, investigating the nature of the stationary points. Then asymptotes, here you check whether it is vertical, slanting, or horizontal, and then also determining the region where that curve has got restrictions. Now, the moment you have those 4 things, it means that you can be in position to sketch your curve. So the moment you have the intercepts, the nature of the stationary points, the asymptotes, and then the sketch. Now, some of you, or sometimes, you may also use the other alternative approach of differentiating. Like some of you love differentiating, whereby you get your dy dx. After getting your dy dx, then you find the nature of the turning points, whether it is minimum or whether it is what? It is maximum, which is also very, very fine. Then when it comes to the asymptotes, you need to clearly show how you are obtaining the what? The asymptotes. But I was very happy still with the presentation that he has showed you how to utilize the calculator to make some of those calculations a bit more quick, because many times we waste or we take a lot of time feeding in the values one by one, and at the end of the day we are unable to complete. So using your calculator very well will help you finish on time, but also will minimize on the errors that you do make. So plan better on how to utilize the calc, more so when it comes to putting in those functions. Yes, and when you are putting in functions that involve squares, that involve cubed, that involves power 4s and the rest of that, always ensure you put a bracket such that the calculator may be able to square the bracket. When you are putting in values like x squared in your calculator, many times the calculator may not be able to square this. So for such things, when you are punching in your function which has a square, always put a bracket and then you put what? A square, such that the calc may be able to square. But the moment you just write your function like this, then the calculator will give you a value that is not correct. So I'm going to ask Kasha in secondary school to first put for us that part when you are putting the calculator, using the calculator, such that everyone can see it now clearly. I want you to put for us a function, because I know we have students that maybe have not used that approach of putting functions when you are feeding in the values. So you place back the calculator and you put at least one function such that everyone can be able to see it. Yes. When you are putting that function that has a squared, yes, I'm going to ask you bring back the calculator and then punch in for us just any function. Okay. Okay, I want us to, you punch for us the function which has a square, like, yes, any function, and you tell us the step how to do it on a calculator.
All right, so I'm going to put maybe this function here, which is y equal to 2 into x squared minus 4 out of 2x minus 5. Let me see if I can. Okay. So I'm going to open bracket. Let me see if I can use this calculator here. Are we able to see what is on my screen?
Not yet. Your camera is off.
Okay. So let me put this. So for example, I want to put y equal to 2 into x squared minus 4 out of 2x minus 5. So I'm going to open brackets 2 times because whenever I open a bracket, I have to close it. So I'm going to open the first bracket. So I'm going to open the first one for putting the function. So I'll put 2, then I put this bracket into x. So the x is here. It is in this purple color and it is corresponding with the alpha. So I'll press alpha and then where I see x on this bracket. So the x is coming. Then the square is here on the x squared. So I press this button of x squared. Then now minus 4. So I'll put minus 4. I close bracket. So this bracket is for this. But then this bracket is open without closing. So I'm going to close this first bracket by pressing this bracket here, and then I divide. So I'm dividing by, I open a bracket where I will put this denominator function. So I'll open this bracket and then I put 2x minus 5. So I'm putting the 2, the x is here on, then alpha, then the x button, minus 5. So I'm putting minus 5. Then I close this bracket. So this bracket is for this other one. So I'll press this button, which is named calc and is also having solve. So I press this one. So when I press it, shows me x. It is asking me the value of x. So like here in the empty sections part, the x values are these ones which are here in the range. So I can now pin in any value of x which I want and it will give me the solution. So for example, when I had x less than negative 2, I used maybe negative 6. So when I press equal signs, it is giving me the sign being negative. Is that all right?
Thank you so much. That is very okay. So dear students, you can learn how you can use the calculator such that you can be able to minimize on the time you take on. Okay, thank you so much, Kashanyi Secondary School, for that wonderful presentation. I'm going to request you to scan your presentation. After scanning the presentation, then you go on and share with us the presentation in the chat such that people who came in a bit late, they can be able to share or to see how you have been able to discuss. Then I would also want to remind you, dear students, when it comes to discriminants, hope we know the discriminants. Please take note that we have three conditions for what we call real and distinct. So we have what we call real and equal. Then we have what we call real, distinct, and rational. And then we have what we call real, distinct, and irrational. But also we have what we call unreal and imaginary. So when you are dealing with real, distinct, and rational, we do expect for you to have the greater. And then in case they are real and equal, then it is better to have greater than or equal to 0. So you need to pay attention to that such that we can be able to do such numbers. But thank you so much. We shall be waiting for the presentation to be shared in the chat. Okay, next, I want to check whether Chinoni is ready. Chinoni, kindly let me know which device you are using. Chinoni, which device are you using? Okay. Okay, teacher Ayebale? Okay, teacher Ayebale? Okay. Let me spot. This is Chinoni School. Kindly, teacher Ayebale.
Yes, please, thank you. We are ready to present. Yes, please, thank you. We are ready to present.
Okay. So they are going to share their screen. I don't know which screen teacher Ayebale we are using.
Yes, please allow us to share the pin.
Yes, teacher Ayebale. Okay.
Allow us to pin.
Okay. Also, we shall request, I think there's too much lights in the room. They have proposed that you close the door. Okay.
Yes, please. I have, yes, now we are ready to project our screen.
Okay.
Raise come for us there.
So we are going to have one question from Chinoni. Then when they finish, we shall go in for another school, Palabo, you prepare, and Itula. Okay, we can start. I'm going to Teacher Cliff.
Yes, please.
Yes, I'm going to request that you join using the phone such that you use the phone to show us the screen. So we are going to give you some time. Join using the phone. Then let's use the phone to show what the student is going to be working on. So I'm going to call you again.
Now I'm ready.
Okay. I'm not. Okay, just a minute because I'm not seeing that screen you are showing.
Maybe I have the laptop and the PC, and I have two names there which joined the meeting.
Okay, which other name?
They are all Ayeba Cliff.
Oh, I'm saying there is one now. There's only one Cliff. So Teacher Cliff, first join again, and then we call you back. We call you back. First join using the phone, and then we disconnect the microphone on the laptop, and then we focus on the chat using the phone. Okay. Let me check Itula. Itula, you can unmute. We can have you. Let's first have Itula as Teacher Cliff joins again, and then we have you all back. Okay. Itula, we can have the student.
Yeah, we are ready. This is
Okay.
Tula Secondary School, and trying to position the camera clear. We are using the blackboard.
Okay.
We are using blackboard, and here a student with us. He's going to tackle question 12 of that paper. I hope the camera is clear, and my audio, the audio is clear as well.
Yes, you are clear.
Okay.
Yes, good morning, dear mathematicians. This is me once again, Jansuk Philip from Itula SS, and I'm going to present question number 12. So question 12 says, express 6x squared minus 24x plus 15 all over x plus 1 x minus 2 squared. That is to express this given expression in partial fractions. So here, the first thing we do is we first identify.
Teacher?
Like, yes?
The words are not so clear on the blackboard. Can we move the camera closer?
Okay, okay. I don't know whether it's clear there.
Yeah, better.
Yes, thank you. I was at the point of saying, when you find a question to be, or an expression to be expressed in partial fraction, do not be excited that this one is partial fraction and it is very easy for me to handle, or I can use even 3 minutes to handle this. Yeah, it is easy if you understood all the steps that are needed in expressing a fraction into partial fractions. So the first thing you have to do is you identify, is this given fraction, is it proper or improper? So how do we identify that this one is proper or improper? You simply use the powers in x. The highest degree here of x is 2. And if you check the denominator here, the highest degree is 3. It implies that this fraction modifies to be a proper fraction. Now, if the highest degree of x in the numerator is equal to or is greater than that of denominator, it implies that that given expression is is improper. So if it is improper, you first use long division to divide. But for the case of this one, it is proper because here, this one here is x squared. And if you multiply it by this x, it will push you to x cubed. And here we can see that the powers of x, it is square. So it means the one in the denominator is greater than the one in the numerator. This qualifies to be a proper fraction. So if you have identified that this one is a proper fraction, you can now let. So you can put your, you can say, let this expression be equivalent. Remember this part here, equivalent. We are not using equal sign. We are using equivalent sign. So it will be equivalent to. And then you also come here. The other thing is, you now check the denominator after identifying that the equation or the expression is proper or improper. Then you check your denominator here. Like, is it linear? Is it repeated root? Like, is it quadratic, which is not factorizable? Or is it containing a difference of 2 squares? Then you identify it from there. So for our case here, we are having a linear and a linear equation also, but it is a repeated root. So for linear, it implies that your numerator is going to be a constant. If the denominator here is a linear, your numerator here is going to be a what? A constant, which is going to be out of x plus 1. Then you say plus, this one is a repeated root. So for repeated root, the numerator as well is a constant, but you write the repeated root in ascending powers up to the highest degree or the maximum degree given in the question. So here our highest degree here is 2. So we are going to write this one also to be constant over x minus 2, then plus c over x minus 2. Then this one will increase by 1 to be 2. So here the highest degree is 2. So we are going to stop at it also 2. We're going to continue from there. If it's supposed to be 3, then we say plus d over x minus 2 plus x minus 2 cube. But since it is square, we are going to stop in square also. So here now, the LCM of this and the LCM of this, it is the same. So using mathematical line, if you cross multiply, it implies that the LCMs will cancel. So here you have your 6. This implies that 6x squared minus 24x plus 15 will be equivalent to this one times this. We are going to have A into x minus 2 squared plus B into x plus 1 x minus 2, then plus your C into x minus, not x minus, x plus 1. So after expressing the equation in this form, now here what we are interested in is to eliminate some of the constant so that we get some of the constant. Now here, there are two formulas of eliminating this constant. One of it is by expanding these expressions here. And then secondly, by using suitable values of x. So for me, I say using suitable values of x to eliminate some of these constants to be the best way, because even if you expand this expression again, you are going to substitute for values of x, or you're going to equate the corresponding powers. But I see that for next wastage of time as a senior mathematics, you need to use the shortest approach for you to come up with the right answer in short time, because remember, we are fighting against time. So here, I am going to use suitable values of x to eliminate some of these constants, say A, B, and C. So here putting your x to be equal to, you say 2. And if you are using this formula, what you need to do is, you need not to use bigger values. You use values that can correspond and eliminate some of these constants. So you can see that if you put 2 here, 2 minus 2, it is 0. So it means A minus 0, it is 0. You have eliminated A. Again, here also you put 2 here, you see that 2 minus 2 is 0. So it has eliminated what is B. And you will be left only with the C. So let us put 2 here. If you put 2 here, you get that it is 2 squared, which is 4. Now 4 times 6, it will give you 24 if you use your calc. Then minus 2 times 24, which is 48. And then plus your 15. Yes, plus your 15. And then now, you can see that here now we are using equal sign because we are going to remain with it a one constant. So here, this one will be 0, this one will be 0. If you put 2 here, you get 2 plus 1, which is 3. You multiply it by C, you get your 3C. So this one, using the mathematical eye, you can see that if you subtract this one from this, you get negative 24. And then negative 24 plus 15, you get your negative 9. Mathematically, you have here negative 9 is equal to 3C. So if you divide both sides by 3, you get your C to be a negative 3. To be a negative 3. Then you move forward also, seeing that if you put negative 1 here, it will eliminate this, and this one will be 0. As well as here, if you put negative 1, it will eliminate this also. So, yeah. So here, as well, I'm going to say put in x equal to negative 1. So put negative 1 here, you get positive 1. Positive 1 times 6 is 6. And then put your negative 1 here, times negative 24, you get positive 24. Plus 24 plus 15 should give you that. So if you put here negative 1, you realize that you will have negative 3. Negative 3, if you square it, it will give you positive 9. Positive 9 times 8, you get 9a. This one, you put your negative 1 is 0, this one is 0. So if you simplify this, you will get this one to be 30. 30 plus 15, you get 45, which is equal to 9. If you divide both sides by 9, you realize that your A will be 5. I hope we are understanding. So let's move forward. Here now, you have A and you have your C. You are remaining with the B. What next to do? After getting some of the constant and the remaining with one constant, you can use now any convenient value, but it should not be very big. You see the range is here. This one is 2 and this one is 1. So you can use maybe 0. So let's say put in x is equal to 0. If you put your 0 here, you realize that this one will cancel, this one will cancel, and you remain with 15 only. So your 15 will be equal to, if you put here 0, you get negative 2. Negative 2 squared, it is 4. Now you have 4 times your A, which is 5. You get what? You get 20. You get your 20 here, and then you come here. If you put here 0, this one will be 1. If you put here 0, 0 minus 2, it is negative 2. Negative 2 times 1, it is negative 2. Times b, it is negative b. So you have your negative b, negative 2b, and then here. And then moving forward to this one, if you put 0 here, this one will be 1. 1 times c, which is negative 3, you get your negative 3. So here, using a mathematical eye, you can see that this one minus this, you get 17. So if that 17 crosses the other side to be 15 minus 17 to give negative 2b. So here you can see that this one is negative 2, which is equal to negative 2b. Divide both sides by negative 2, you realize that your b will be equal to 1. Let me hope we are not getting lost. I believe we are on the same track. Here you get your b to be negative 1 using your mathematical knowledge. There's no need to waste time there. So we have gotten the constant. That is to say A, B, and C. So what is our next step? From here now, since you have gotten the A, B, and C, we are going to say, therefore,
Itula, I want us to focus the camera very well. The camera. Yeah. Because
Okay.
I'm seeing sometimes the picture is very clear, another time is not so clear.
Okay. Let me try to put the camera well. See whether I don't know. From there,
Not
is it
yet.
clear?
Not yet. Not yet. Not yet.
There at least?
Not yet. Not. Is lighting on?
There's no light. Not yet clear?
Not yet. Not yet. You try to stand in the sideways. Where the light is coming from, maybe.
No coming.
Not yet. It has not yet come very well. First close the door, maybe. And we see. Not yet. Then maybe just stand in the middle and we shall just.
We are using a web camera, Logitech type, and
Okay.
not yet clear.
The light is too much in the room, I think. But we can continue. Let's continue.
Okay, so welcome back. I was at the point of saying we have now found our constant A, B, and C. So after getting all the constants, then we can now say, therefore, let this given expression be equal to, okay? Be equal to. You be careful here because we're using equal sign. Why? It is because we have gotten the constant, which is A, B, and C, and that's why here we are now using an equal sign. But here, since this one were unknown, we were using equivalent sign. So we shall have our A, which is 5 over x plus 1, and then plus our B, which is 1 over x minus 2. And then our C is negative, say minus again x minus 2 squared. Then you say hence the partial fractions. So simply that is all about question 12. That is part A. And moving forward, we are going to look at also that is the B part of it. So question 12, the B part of it is saying that hence obtain the expression of this, the expression of the given fraction there in ascending powers of x up to and including the term in x squared. So Then this one is part B. For the hands part, from your 6x squared minus 24x plus 15 all over x plus 1 x minus 2 squared is equal to a 5 over x plus 1 plus 1 over x minus 2 minus 3 over x minus 2 squared. This will be equal to, so this one here is the loss of indices. You can see that this one is the same as 5 into x plus 1 power negative 1 plus x minus 2 negative power 1 also, then minus 3 into x minus 2 negative 2. So here, I think using a mathematical eye, you can see that I have not changed anything here. This expression is the same as this one here. So we are asked to obtain the expansion of this. So simply here, the logic is they are testing whether you can remember how to expand this one, this binomial expression here. So we are going to deal with this one after the other. Then we shall add them at the last time. Because if we say we're going to write them all, the space will not be enough. Remember our sheet of paper here, it is having limited space. So what is important is you first pick this, you expand it, you pick this, you expand it, and you also pick this, you expand it. Then at the end, you also align them. So I am going to begin with this. So this one should be equivalent to so I think you can see that I have not changed anything between this and this. This expression is still the same as this one. But the question may come that why is it that I'm bringing one this side and I'm taking x the other side? The reason is because they have asked us to obtain the expansion in ascending powers of x. So in binomial expansion, if the powers of x, okay, like if you're expanding a certain linear equation or a certain equation like this, it is always a must that the first value here will be the powers of this one will increase. Yet, while the powers of the other figure or the other value in the right hand side will keep on increasing. As this one increase, this one the powers increase. So they have asked us here that we should obtain the expansion in ascending powers of x. So it means we have to bring x this side so that its powers will be increasing. Ascending means something which is increasing constantly. If they have to say in descending powers of x, then we shall bring this x this side, and then we shall take the other one, the one the other side. So I hope you have picked me clear why I have interchanged the position of 1 and x. So here now, it is simple for you to expand this one now. So,
Okay, a minute. Teacher, they are requesting if we can block that light from the window on our left. Is it possible? And then, okay, teacher, have you been able also to join using your phone?
The phone cannot be because they're charging and it has a low battery.
Oh, okay.
Still not clear there. We have closed the window and
Okay, can you first project the first screen, the other side where you started from? Maybe we see.
okay. So it's here.
At least I think let's use this side at least. We can see
Okay.
something. And let us focus on the speaker's board only.
Okay. Okay.
You can as well try to clean the camera and we see. Okay. Let's focus on that side.
Did you see him? He's not there. Yes?
I'm seeing another Itula. Oh, okay.
yeah, I have been running the blackboard. So, as we have seen, okay, let me begin part here first.
No, 4. From 4. 4 from there.
So, I think I've explained this one before, why I've interchanged the positions or the directions of 1 and x. So here, now I'm going to expand. So expanding this one, I can choose to first pick the bracket and its power here, then keeping in mind my 5. Or I can go with all of them, but it will also be a little bit, your work will look complicated. So it is good for you to keep this one in mind, and then you first deal with this. Then after getting the answer of this, you also bring back your 5, and then you multiply it through. So I'm going to keep this 5 in mind. I will have 1 plus x negative 1 to be equal to 1 plus, you drop the power, you multiply it by this value here, which is x, over 1 factorial. X here is having power 1. So the power of x reflect the factorial down here. Plus, you maintain this negative 1, and then you reduce it by 1 to give you -2. And then you also pick this, which is x, but this time now, it is squared over 2 factorial. As I've said before, that the power of x reflects the factorial down here, plus. Now here, they have given us a condition or a range where to stop. They have said in ascending powers of x up to and including the term in x squared. So it means we're going to stop in x squared because that is where they have limited the range. So it is always recommended for you to put 3 dots so that the expansion is still continuing, but because I am or you have been restricted, you are stopping here. So this one, if you simplify this, you get your 1. This one will be minus x. 1 factorial is 1. So any number or any constant divided by 1, it is that number itself. Here plus. This one times this, it is positive 2. 2 factorial is 2. So this 2 will reduce by this to give you 1. This one, if you square, it will be x squared. So you'll have here x squared. So here now we are not putting the 3 dots simply because this is where they have restricted us to end. So we are ending here. So remember, we are keeping 5 in mind. So this implies that you have 5 into x plus 1 -1 is equal to, now you multiply this answer of yours here by 5. So if you multiply this one by 5, you get your 5 a minus a 5x, and then a plus 5x squared. So for the first case, we are done. So we are moving forward to look now at this one. We are done with this. This part here we are done. Now we are going to this. Let's also deal with this afterwards. So let's take 2x minus 2 raised to power 1. So for x minus 2 raised to power 1, the same way we have deal with this one here, you say this one should be equivalent to -2 plus x -1. This one here, our aim is to make this one to be 1, so that our working will be very simple. So making this one to be 1, it means you have to pull out -2. So if I pull out -2 here, I'll have -2, not forgetting its power here. And then this one here will be 1, a minus x over 2. So using your mathematical eye, you can see that I have not changed anything here. If you open this bracket, you still come back here. So I have not changed anything here. So moving forward, if you simplify this, you will have -1/2.
Okay, teacher, there is a comment in the chat. I don't know whether we can effect it to do
Yeah.
something. Have you been able to see that comment?
No, I'm trying to focus on the camera. Maybe you read for me that comment.
I think there is a way we can click on the video and we change the background.
Okay.
Let's check whether you can be able to see that option.
to some, I can.
Then also they are suggesting if you can put it in portrait option. Okay, let me ask Church of God. Church of God, can you guide? Church of God, unmute. And then you guide us. Yes, Church of God. Okay. I think I'm failing to get Church of God. Okay. Church of God, you can unmute. You are unmuted. Okay. Teacher, let's continue.
Are you seeing at least somehow there?
Yeah, we can continue now.
Okay. So we were at the step of simplifying this. So if you simplify this, it means you're going to rationalize. So if you rationalize this, you get a half, and then this one here remains 1 minus x over 2 to the power 1. So the same way, I'm going to keep this negative per half in mind. Then I first deal with this one. Afterwards, I will introduce my negative per half. So I can say 1 minus x over 2 negative 1 should be equal to the same way. We keep this one 1 plus, because here this one first we call power at first, but 1 raised to any number, it is 1. Even though you raise 1 to 1,000, it will still give you 1. So it does not you will not be penalized if you put here just 1 without the power. Then plus you drop this power, which is negative 1, then you multiply it by this, which is a negative x over 2. Then over a 1 factorial. Plus, you maintain this power, negative 1, you reduce it by 1, you get negative 2. Then you multiply it by this second term here, which is negative x over 2, but this time round square over 2 factorial. Plus, you have 3 dots. So here, you need to be very careful. So long as it is negative here, it means this negative is for all the x term. So you need to bring it with its side. If it is positive, you are lucky. But if it is negative, and in your mind you are harassing, and you happen to pick only x over 2, leaving out the negative, you have now penalized yourself and you have lost the marks. So be careful. If this one here is negative, you have to see very clear that it is always here where the x term is. So let's move forward. Simplify this. This one there will be positive plus a half x. This one there is positive. This one there is positive. Plus this one times this is 2. Which reduces, this one will be 4. If you reduce this by this, here will be 1, here will be 2. These 2 will multiply this for you to get a 4. So you will have 1 over 4x squared. So from here now, remember we kept our negative half in mind. So we will introduce it now in this step. So we say this implies that your x minus 2 and then negative 1 is equal to, we multiply this 2 by negative a half. So 1 times negative a half, you get negative a half. Negative a half times a half, you get negative a quarter. Negative a half times a quarter, you get negative 1 over 8x squared. This one here is x, sorry. So I think we are clear with the second expression here. Let us go forward to the last equation. So for 3 into x minus 2 negative 2, the same way we're going to bring this to the other side. I hope by now you know why I'm doing this. You have your negative 2 plus x negative 2. This one should be equal to negative 2 into 1 minus x over 2 power negative 2. So if you simplify this, you get your 1 over 4 you get negative 1 over 4 into 1 minus x over 2 negative 2. So here now, the same logic that we have used in the previous example or in the previous expression, I mean, we're going to also apply it here again. You keep this negative a quarter in mind, then you first solve this and we introduce the a quarter in the last minute. So when we wrap up this, I hope we have picked it clear. So we are going to keep our negative 1 over 4 in mind and the first deal with the bracket. So we shall put here 1 minus x over 2 into negative 2 or raised to power negative 2 should be equal to your 1 here this one plus to bring this power down, which is negative 2. We multiply it by this negative x over 2 over 1 factorial plus maintain this negative 2 and then reduce this negative 2 by 1, you get negative 3. After that, multiply it by this negative x over 2 squared, then over 2 factorial, plus the continuation sign. So here, simplify this one further, you see that this one will remain 1. This one here will be positive 2x, which is reduced with this will be x plus x. Then you come here. Mathematically, this one times this is positive 6. And then this one here, if you square it, you get positive x squared. This one, if you square it, you get your 4. So, using the mathematical eye, you can see that here you have 6 and here you have 4. So you can reduce it by 2. So 6 divided by 2, you get 3. So 4 divided by 2, you get 2. So it means we are going to have here 3 over 2 divided by 2 factorial, which is also 2. Now this 2 is going to multiply the denominator here to give you 4. It means finally, this expression, if you are flexible enough in your mind, you can say that and you can agree with me that you'll be having a plus 3 over 4 x squared. Then, after this, remember, we have kept two values in mind. We kept 3 and we also kept this one here, which is a quarter. So, mathematically, in your mind, there is no need to write this also down. We just say that this one times this, it is negative 3 over 4. So, it means now, this equation, we are going to multiply it by 3 by negative 3 over 4. That is mathematically, if you are flexible in your mind. So mathematics is just a matter of being flexible and there's nothing much. So here, I can now say that this implies that my expression here, which is a 3 into x minus 2 and negative 2, the same as I've said, we are going to multiply this here by negative 3 over 4. So, in your mind, be flexible. Negative 3 over 4 times 1, you get negative 3 over 4. This one, you get minus 3 over 4 x. Then if you multiply this one by 3 over 4, 3 times 3, it is 9. So you have minus 9 over 16 x squared. So here now, we are going to do what? We are now going to add them. So we are now coming to the conclusion. You say therefore, you have 6x squared minus 24 x plus 15 over x plus 1 x minus 2 square is equal to, now you start arranging this one. Our first answer was 5 minus 5x plus, I think 5x squared. And then our second expression is here, which is negative a half minus a quarter x minus 1/8 x squared. Then our last expression is this one. But here also there's something unique. Remember, here we are having negative. So in our thing, we skipped the negative. So it means we are going to again multiply this one by -1. So if you multiply this one through by -1, you're going to get positive, positive, positive. So it means you're going to have here 3/4 plus 3/4 x plus 9/16 x squared. So you can use your calculator now to obtain the answer here. So if you press in your calculator, you first have to check whether your calculator is in degrees. If it is not, then you first have to reset it to be in degree. So you say you are 5 minus a half minus 1/2. After pressing your 1/2, after pressing 1/2, then you say plus this one, which is 3/4. So you get here 21/4. And then you also press this one. You say -5 minus a quarter, which is 1/4 plus 3/4. You get minus 9/2. You put your x. And then you also come to this, which is 5 minus 1/8 plus 9/16. You get here positive 87/16 x squared. So, dear mathematicians, we have come to the end of our question 12. So, in case of any inquiry, more clarification, or a question, I think this is where I am going to stop. And in case of inquiry, it's welcome. Thank you.
Thank you so much, Itula, for the wonderful presentation. Those who may have questions, we can ask. Yes, Nama SS Mitiana. Unmute. Nama, okay. Aisha Gauss. Unmute. Dominic Farms Koboko. Okay. Nama first, then Aisha Gauss.
When he was adding those terms to get the final answer, Not penalized when they don't include the plus sign there.
Presenter, have you had a question? When you are obtaining the final answer, don't you get penalized?
When you don't include the plus sign there.
Okay.
So yeah, so here you can see that even if you put numbers here, let me say, a minute, because remember, this expression is supposed to be written horizontally, but since you have converted it to be in vertical form, it implies that you can, using your flexible mathematical mind, you can see that any number without a sign is a positive. So here, you just go direct, you just press these values, direct. Where there is no sign, it implies that that value is a positive number. So for a positive number, it implies that in front of any number which is not having a sign, that number qualifies to be a positive.
Okay, thank you. Yes, so for such, we recommend having it in a horizontal form because you may meet a situation. Here it is very okay because the terms were a bit few, but there are cases where you will meet quite a number of them, and you find that if you put them on in the vertical format, you are almost finishing a whole paper. So those who can, in case the terms are many, we recommend writing them horizontally and then have those additions to show that now you are adding the first plus the second plus the third. Aisha girls.
So, good afternoon, comrades. My query is, at the beginning, the presenter told us that we shouldn't use equal signs, we should only use the equivalent signs. But then when the presenter reached the middle of the work, he stopped using the equivalent signs, he started using equal signs. So I need more clarification about that.
Okay, thank you. Presenter?
Yes, I think she was asking in the beginning why I was selecting the expression which is 6x squared minus 24x plus 15 over x plus 1 x minus 2 squared to be equivalent to a over x plus 1 plus b over x minus 2 plus c over x minus 2 squared. So your question was why I was using equivalent sign instead of equal sign. Okay, you see that here, this constant A, B, and C, we don't know their values. So since we don't know their values, you cannot equate that this equation is equal to this because you don't know this. You don't know this one, this constant here. So our aim is to get the constant before we equate. After getting the constant here, then we can now come forward to equate. After getting this one, maybe 5, a 1, negative 3 we have done, then you can now equate that it is true that this equation is equal to 5 over this plus 1 over this minus 3 over this.
Okay, maybe I'll add on. Now, when it comes to partial fractions, like the presenter showed us at first, he used equivalence sign. The reason why he went on to use those equivalent signs is to show us that the two expressions that we are dealing with are identical in form and value. However, after obtaining those constants of A, B, and C, then the final answer and the original expression you add are equal in form because you have obtained. So at the end of the expression, those two are equal. But at first, since we had not yet obtained the unknowns, those ones are just equivalent. It is until you have obtained the value of A, B, and C that now you can confirm that the two are now equal. So in your conclusion, we expect you to use an equal sign because now what you have on the left and what you have on the right, they are the same in terms of the mathematical value. That is the meaning. So equal sign means that what you have on the left is the same as what you have on the right in terms of the mathematical value. But equivalence, here it means that the two things you are dealing with are just identical in nature until when you find the actual values of A and B and C, then that's when you go on to use the equal sign. Okay, then the last person, Jimmy. Jimmy? Okay. Thank you so much, Itula. I'm going to request Itula to have that solution noted down and then scan for us that solution and then you share with us in the chat such that people can be able to follow up what you have been able to discuss. Thank you so much. Thank you so much.
Thank you so much for the privilege and opportunity for having presented, and wish next time to improve on our camera. Please, people in the comment section, we are so sorry. We shall improve on the camera and next time be better. Thank you.
Okay, thank you so much. Okay, I want to now check on whether Chinoni, we are ready. Chinoni? Yes, the questions, those schools that have just joined in, the questions are in the chat. But also we request that the schools that are online to take just 3 minutes to fill in the registration form that we are putting in the chat. There is a registration in the chat. Okay. Chinoni, kindly let me know whether we are set. Chinoni, as Chinoni, I'll ask Parabo Secondary to get now your camera very close to the board because you're going to be our next presenter. Parabo? Yes, Chinoni, let us know whether you are set. Chinoni, are we set? Kindly let us know.
Yes, I'm preparing.
As Coach SS, you
Yes,
also...
I'm requesting you to unmute Chinon SS because I'm trying to use it so that I use the microphone.
I'm seeing only Chinoni high.
Yes, then there is also Chinoni. There is a Cliff.
Okay.
Yes, thank you.
So to avoid the background noise, you will mute one of the microphones that you're not going to use. Which one are you using, Teacher Cliff? Teacher Cliff, let's focus on the chat. Okay. Now, Teacher Cliff, then I'm going to request you that, okay, that is okay. Can you first try to hold the phone in the landscape format?
Number 38, and the part A is like differentiate exponential kx from first principles. We are letting y to be our exponential kx s s s y plus small change in y equal to exponential k 2x plus small change in x. A small change in y, just open the bracket, kx plus k delta x, then minus our y, but our y was our have exponential kx. Our delta y equal to, we add the powers, we apply the indices, multiply, this is kx dot exponential k delta x minus exponential kx. Simplify, this is common. Exponential kx into exponential k delta x minus 1. Then we have this one. Go back to the log table, the analysis. Then the expansions. So on page 62, then expansion number 46. We are seeing that expansion of exponential x is equal to 1 plus 1 plus x n plus x squared over 2 factorial n plus x cubed over 3 factorial plus dash 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 n plus x power n over n factorial for all expansion of x. But now we check our x, instead of having x here, we're having k delta x, meaning the expansion of this one, where we have x, we are substituting k delta x, meaning our exponential now, k delta x is equal to 1 plus k delta x plus k, small change in x, all of it squared over 2 factorial plus dash 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 up to our k delta x power n by n factorial, meaning small change in since delta x is less x, means that delta x squared approximate to 0, meaning all other expansions involving high powers of x squared and above cubed up to power n, they are all approximated to 0. Then we substitute back our exponential k delta x equal to 1 plus k delta x, substitute here. For change in y equal to exponential kx to 1 plus k delta x minus 1. 1 minus 1, 0. And small change in y is equal to k delta x exponential kx. And we divide both sides by delta x, both sides by delta x. This one is cancelling out. I have a small change in y over delta x equaling to k exponential kx. Then as delta x tends to infinity, then our delta y, delta x approximate to dy by dx, meaning our dy dx is equal to k exponential kx. That's our final answer. Originally we had y equaling to exponential kx. When we do it directly, we get the power, it is k, then drop the derivatives here, it's k, then the exponential back with its power. First principles from all those steps is our final answer. So as our part A. Then go to part B. Study H part B. Use small changes to show that 16.02 power a quarter is equal to 2 using smaller changes. Then let our y be equal to x power 1 out of 4. Let's differentiate y x is equal to drop the power, then power minus 1. That is 3 out of 4. Then know that y plus its smaller change in y will be equal to x plus its smaller change in x by the whole of it power 40. You have to get x and smaller change in x. Our x be that number that when we raise it power a quarter, we get a direct value. We can get our calculator having 16.02 10 to power a quarter. We are getting 2.00624. Then our number, our integer, without whole numbers, it's the direct value. And when we power it power 4, we get the number which is near this one. That when you get it power a quarter, give us a direct number. Gets 2, then we power it 4, 16. Meaning we have 16 y plus motion in y equal to 16 plus get this 16.02 minus this, the remaining is 0.02 power a quarter. Means that by comparison, x is equal to 16 and delta x equal to 0.02. Then we apply back our x in our dy by dx equal to a quarter, then 16 power negative 3 over 4. Power negative 3 out of 4, then times a quarter. We are getting 1 over 32. Then want our small change in y now. Small change in y equal to y x times small change in x. This is 1 over 32. Our small change in x was 0.02. 0.02. Getting 1 over 1600. Then back our y plus small change in y equal to y. We have it here. X power a quarter plus small change in y, which is 1 over our x is 16 power a quarter plus is 2 plus 1 over 1600. LCM 1600 then 2 times 1600 is out of 1 then plus 1. Which is 3201 out of 1600. And from the calculator, in mixed fraction, is 2, 1 over 1600. So this is our part B.
Presenter, can you show us how you have obtained that on a calculator? Clearly show us the calc such that people can see how to obtain it.
We had 3,201, then out of 1600. This was our answer. Then we use this button. For improper fraction or proper, we press shift and this button. This is our proper fraction or improper. Then for mixed, we simply press this button. This is our whole number, 2. Then 1 out of 1600. This is the fraction. This is 2 whole number. Then 1 out of 1600 as our fraction, as represented here in the chart. Can we go for part 3? Then let's go to part C. Number 38, part C. They are saying that differentiate exponential 5x cos 2x over ln brackets 1 minus x. Let's let our y equal to function given exponential 5x cos 2x over ln 1 minus x. Let's use quotient rule. dy x equal to, this one constant, differentiate the power. Let's apply product rule. Keep exponential e 5x constant. Let's differentiate cos 2x. Differentiate the angle, get to differentiate the ratio, getting negative sign. Then back the angle, 2x. Then plus. Now keep cos 2x. Then we differentiate exponential. Drop the power. We differentiate the power, getting 5. Then exponential 5x. Then minus. Now keep this one constant. Exponential 5x cos 2x. Then we differentiate. Differentiate the bracket, negative 1 over original is 1 minus x over 1 minus x squared. Let's try to simplify y dx equal to then 1 minus x minus 2 exponential 5x, then sine 2x, then plus then 1 minus x, then cos 2x, then minus this minus, my first this one become a plus exponential 5x cos 2x over 1 minus x, dividing it by 1 minus x, all of it squared. Let's try to simplify. This one is common. Then I have a common factor there, plus exponential 5x, then 1 minus x, then plus 1 over 1 minus x, then our exponential 5x cos 2x. Y dx is equal to, simplifying this one, this is 5 here. That cos 2x into 5 exponential 5x. This 5, let us try to follow it. This 5, this one is here. This one, this is 5. It's there. Now we are okay. mean 1 minus x minus 2 exponential 5x sine 2x plus mean 1 minus x. Our 5 is there. Exponential 5x cos 2x plus 5x cos 2x over 1 minus x. Just put this e exponential 5x cos 2x mean 1 minus x exponential 5x sin 2x plus exponential 5x cos 2x 2 is 5 natural logarithm 1 minus x n plus 1 minus x n over 1 minus x squared. Then let's also put this exponential 5x 1 minus x sin x plus cos 2x into 1 minus x LCM then 1 minus x plus 1 over 1 minus x. It's there. Then divided by then 1 minus x, L of it squared. Yeah. Other simplification. Finally, our dy dx is equal to exponential 5x. Our LCM here 1 minus x natural logarithm 1 minus x sine 2x plus 5 cos 2x and into 1 minus x natural logarithm 1 minus x plus 1 over 1 minus x in 1 minus x of it squared. That's our final simplification. This is the answer. Our finished. This was 38 part B. Part C, sorry, from here to here. This time, let's allow some questions.
Okay, those who may have some questions, presenter, you are going to take us back from the first part to the second part to the third part in a slow motion. Okay, so let's have any questions? Okay, yes, BISS.
Yes, good morning. I'm Lagu from BISS Ajuman District. I want to inquire something about from small change in Y. Is it approximating or is equal to?
Okay, they are getting there. Pakada Seeds SS.
Good afternoon. I just want to inquire from the introductory part how you differentiated ln z ln of 1 minus x, and also try to reduce on your speed. We are all some are slow learners. Thank you.
So let's be attentive. It's right, so I think you pick it.
Okay, can you answer those questions?
It's not for the camera, it's just.
Oh, you know that.
Yes, presenter, we're waiting for you.
It's up here. It's up here.
Okay, I'm going to share my screen shortly.
That is not the That question was not taken.
Okay, now one participant asked, how did the person differentiate lane? Now, when you look at what we had, it was lane of 1 minus x. This is what one of the schools. Now, when we are differentiating the natural log of lane, remember, we can first, you need to know from the principle that whenever I have ddx of ln of x, this one is the same as 1 out of x. That whenever you differentiate ln of x, you end up with 1 out of x. Now for this function we have, if I may just let and say that let y equals to ln of 1 minus x, I am putting in the magnitude to show you that we cannot have a natural log of negative. Now here you can use the change of the variables. So you can say that let my u equals to 1 minus x. Now that means that your original function is going to be y equals to ln of u. What are you going to do? You know that when I have d, dy, dx, and I've changed the variable, I can use dy, du, then times du, dx. Now, what does it mean? Here, when I'm differentiating, I'll have dy, du, which will be when you differentiate ln of u from this original principle that ln of x is, when you differentiate ln of x, you get 1 out of x. So similarly, when it comes to ln of u, you'll have 1 out of u. Then when I go back to where I have my u equals to 1 minus x, when I differentiate the u with respect to x, I'll differentiate 1 minus x. When I differentiate 1, I get 0. When I differentiate negative x, I remain with negative 1. Because remember, in differentiation, you drop the power, which is n, then you reduce the power by 1. So when you look at negative x as a power 1, so when I drop, I get negative 1. I reduce the power by 1, I end up with x power 0, which will be negative 1 times 1, which gives us negative 1. So when I come back here to substitute dy du, I obtained it as 1 out of u, then times du dx, which I obtained as negative 1. So this will give us negative 1 out of u, which will end up with giving us negative 1 out of our u, which is 1 minus x. And this one still, in case you want, you can still write this same expression as, remember this is negative, so someone can as well write it as x minus 1. Because this negative, when it comes down, it affects. So this is like writing 1 out of negative of 1 minus x, which you can write as 1 into x minus 1. So you can write it. So that is how you differentiate that given expression. Then let me just look in the chat whether there is any concern. Okay. Then the other part of using equals, we recommend using the approximations. Then also I want to bring it to your attention that last year it was observed and it was noticed that many times, sometimes as students, we do fail to get some of or pass some of these numbers. But reason being is that we don't know how to utilize the UNEB time, the tables that UNEB provides. Sometimes because it is an exam, we are panicking, we are on hurry. So sometimes we do forget some of these simple things, and we end up failing some numbers. And therefore, dear students, as you enter into any paper, be it paper 1, paper 2, ask for the time table, ask for this UNEP table, which has almost all the formulas, such that in case there is anything you have forgotten, you can easily go back and refer to it. It has a lot, and sometimes some of these formulas we are using, we keep forgetting and we keep making some small errors. When you look at the percentage of students who failed to obtain an A last year, partly it was because of the of missing out a few things that they did wrong, yet some of those formulas were here in the table. So in case there is anything that you maybe you have forgotten something, you are not so sure, come back here in the table and check out, ask for this table. It is okay for you to ask for it, such that you can be able to check out in case there is anything you have forgotten. Even the binomial formulas, you'll find them here. So just ask for the table, check out all these formulas such that you can be able to utilize them when you are doing your paper. some of those formulas you're asking for, they can be easily obtained from here. Even when it comes to analysis, it has come to differentiation. Like you saw in the question where we had cos and the rest of that. You can come here and check for it such that you do not mess up with the differentiation, you do not mess up with the integration. So some of those formulas are being provided here. So when you learn to use it, you'll find yourself that you do not need to cram a lot of things, but some of these formulas are already provided here in the table. So learn to utilize it such that we can be able to perform much better. Another thing that I want to highlight is going to be on some of the few errors that we do make. Allow me to share my screen that you need to pay attention to. I've already talked about using the tables. Yes, so make sure you utilize the tables very well. Make sure you utilize those tables very well, the mathematical tables for the different formulas. Secondly, your level of accuracy. For numbers that require rounding off, rounding up, and when you are working out, make sure that you maintain the highest level of accuracy. Avoid what we call premature approximations. If you have not yet reached the final answer, please do not round off your figures to 1 decimal place to 2. At least make sure you have 3 decimal places or 4 decimal places that you are working with. In case you are dealing with probability, at least carry the 4 decimal places or more before you reach your final answer. Last year, some of our friends missed because they were approximating prior before they reach the final answer. So you'll notice that the errors that they are going to be carrying, the percentage error is going to be very big. Then the calculator is key. Some of you have not yet mastered very well on how to utilize that calculator. That's why I kept telling the presenter to show us, because you may look at it as something very small, but sometimes we do fail certain numbers because of the what? Because of the calculators. So we need to make sure that we utilize them very well such that we can be able, in case you have not yet obtained a calculator at this point, please obtain it before you go in for your mock examinations. Then these other parts, I'll talk about them when we reach paper 2. Then I want us to always observe when we have partial fractions. Like our presenter had earlier mentioned, that there are basically 3 cases that you need to look at, or there are 3 cases that are being set. And in these 3 cases, these partial fractions, remember, they can appear in section A, they can appear in section B. But when it appears, you'll notice that sometimes it can be integrated with integration or differentiation, meaning that the first part may ask you to decompose a given expression into partial fraction. Then from there, they will ask you to go on and integrate, hence integrate the function. Meaning that if you do not know how to express it as a partial fraction, then it means that you'll not be in position to integrate that given function that they have given you. So as you are dealing with partial fractions, as you are revising, look at the 3 important aspects. Look at the 3 important cases. The first one is when you have the distinct linear roots. And we say that when you have linear, here you'll find that your function will look in this format, like x plus 1, x plus 2. And now in your revision, ask yourself, how do we express this in terms of partial fractions? Like I told you earlier, that here we shall use the equivalence. So I expect you to be knowing that here you will say x plus 1, then plus b out of x plus 2. Then the second case is when we have that proper fraction with repeated linear factors in the denominator. Take an example with repeated linear factors. Like when you have a case whereby you have 1 into x minus 1 squared. When you look at this is a linear factor that is repeated. By repetition, we mean x minus 1, x minus 1. So this is the same factor, but it is repeated twice. But they can as well be repeated thrice, even 4 times. So you need to know that when it is repeated, you need to show that this is equivalent to having a out of x minus 1 plus b out of x minus 1 squared. Now this one is very key for you to remember. Then the other case is that whenever you have a proper fraction with a quadratic factor, you need to know how do you express such a quadratic factor. Take an example, you have 1 out of x plus 1 and then you have x squared plus 2. Now here we do expect that you know that you will say a out of x plus 1 then plus bx plus d out of the function that is quadratic. So make sure that you revise fully when it comes to partial fraction. But also please first always check whether the proper fractions you are dealing with, one, whether the fractions you are dealing with, whether they are proper or whether they are improper, such that you know that in case they are improper, I need first express that fraction in a form that is going to give me a proper fraction by using Longo division. So always check out the degree. Take an example, check out in case I have something like this, out of x squared minus 3, maybe x plus 2. When you check this one, then you ask yourself, is it proper? Is it improper? So please check out that whenever you have here, like in case I call the upper fraction p and I call the downer fraction q of x, whenever you find that the degree in the upper fraction and the one in the lower function are the same or when px is greater than qx, then you know that that fraction you are dealing with is an improper fraction. Whenever you find that the highest degree here is 2, the highest degree here is 2, so that means that this is an improper fraction, meaning that you need first express it in terms of, you have to first express it using long division, and then from there you'll obtain a proper fraction that you'll go on to use. So make sure you revise this part because it can appear in section A, it can appear in section B, but well combined with other parts of analysis. Okay, so that is a brief, and allow me now to invite our next presenter, and our next presenter is Pa. I want to look for Parable Secondary School. Parable, unmute. Parable, okay, give me a minute as I try to get Parable. Parable, unmute.
Okay, thank you so much. It is a Parombo Secondary School, Nebi District. Hello?
Yes, we are very clear.
Thank you so much. It is Parombo Secondary School, Nebi District. And I think our question of discussion, it is question number 2, and the discussants are very ready. I think as we try to connect to our cameras, we are really very ready and set. I think you people, you can move.
Okay, good afternoon to everyone. My name is Igor Jeffers.
Parabo, we can go on.
Yes, we are trying to connect.
Okay, as I was saying, my name is Jeffas, a student from secondary school. So we are going to discuss with you question number 2. And the question says, the expansions of A, the expansion of AX minus 2 power 4.
Teacher, let him write in the middle here where he has been.
I think right in the middle.
Okay, we are going to discuss this question. We said we are going to the expansion of AX minus 2 power 4 multiplied by 1 plus B over X B over X power 3. The expansion of this is written in descending power of X. The first 3 terms of this expansion are 81x power 4 plus 999x power 3 plus cx squared. It is given that A, B, and C, they are positive integers. So we have to find the values of A, B, and C. So now, before we move further, the first thing we are going to do, we are going to expand this bracket using different formulas. We have so many formulas you can use here. You can use binomial expansions, you can use combinations, you can use Pascal's triangle. So you can choose the best you can use. For this case, I can choose to use a combination to expand this bracket. So first, the first thing I'm going to do, I'm first going to expand this bracket, and then I'm going to expand each by each, so after that I get the expansion for every, and then I combine, because if I'm to expand from here and multiply just straight, and then it will be something too bad. Allow me to first expand each, and then we combine and we see what we do later. So expansion of AX minus 2 power 4 using combination formula, you are going to expand it in this way. You are having AX minus 2 power 4 will this equal to, as you know that for a combination, if the other side is increasing, so the other side have to reduce. And we are going to take the value of n for the combination here is 4. This is the highest power which is there. So if I have 4, combination of 0, and then the first value which is given here is 8x. Now, in this case, this one is going to increase. Reason being, we are going to first take to this one, and then we subtract by 0 to give us the power of this one.
A minute. Teacher, there is some echo. Which other device are you using to connect?
I wanted to connect using the phone to make the video clear.
Okay, which name are you using? Oh, sorry. Parabo, I'm going to ask you to unmute again, and then the teacher lets me know which device is using. For the phone?
Yeah. It is called Gmail Galaxy.
Okay. Kind of have the phone's video on and we see.
Is it okay then?
No, start your video on the phone.
Okay, as I was saying,
Okay, turn the camera to the board. Okay, better. Let's use the phone.
Okay, as I was saying, this is how we are going to do it for the combination. If one side is increasing, which means that the other side has to reduce.
Teacher?
Yes, sir.
Let's open the microphone on the phone. Open the microphone on the phone. Open the microphone on the phone. Okay, we can continue.
Let's stand in a way that they are able to see.
Okay, this is how we are going to expand it. We are using by combination. So as we are using combination, if this one is increasing, the power is increasing, which means that the other side has to reduce, which means that we are having two sides. We are having this side and we are having this one. If this one is increasing, which means that this one has to reduce. So we can increase this one by starting with the power 4. We take this power 4 minus this value here to give us this value, and then this one we put this one. So this one, when we say 4 minus 0, you will get 4. Give us the power of this one. And then you will come times negative 2, that's the power of 0. Now, as you can see, this one is increasing. So this one is now, this one has the highest power, so it has to reduce. So this one with the lowest power, so it has to increase. This is what we are going to do from here. So we are going to reduce this one, increase this one. We can have our addition sign in class. If you have combination of now, in taking the combinations, you have to pick in a way that the total of here to here, there is 4, which has been given the highest power. So the best thing now, in this case, means that we are going to pick 3 and 1. So when you add 3 and 1, can give you the highest power of this one, which is 4. So we can have 3 nation of 1. So as I was saying that to get the value of this one, you take this one, subtract by this one to give you the value of this one. Of which this one, for this one, we'll be just putting the power which is down. Sometimes where we go back, we do call it value of R. So this is how we are going to do it. We are having AX, there is the power of 3 minus 1, which is 2, multiplied by negative 2, is the power of 1. And then you add plus. Now we are going to pick 3. We are going to pick 3 and 2. 3, 2, simply because at first this one was 4. Now you see this one is now reducing. 4, we are having 3, we are having 2, 2 and 2. Because when you add the total of the 2, you are able to get 4. They're done, okay? Okay. Why? We are trying to change the rates. Excuse me. Trying to change from the formula. So there is something which is not going okay. And first change the formula, we go to partial triangle. Then first try to change from the formula of the combination to partial triangles to expand this one. This part value minus power 4. B is equal to having, as they said, it's in descending power, which means that from the highest to the lowest. So we shall have this one power 4, shall have negative 2 power 0, plus we shall have ax power 3, negative 2 power 1, plus ax power 2, negative 2 power 2, plus ax power 1, negative 2, this is the power 3, plus ax power 0 power 4. Now you come and pick the value of power 4. This is the power. This is 1, 2, this is 3, this is 4, this is 0. Pick the one of 4. The first value is 1. The second value is 4.
Those are coefficients.
Now the third coefficient of this one is 6. I think the dot product is meaning multiplication and they are not confused. Then when we come here and then we pick 4, the coefficient of 1, the last coefficient is 1. When you open the bracket here, you can find that we are having ax power 4 multiplied by 1 times any number raised to the power of 0, which is 1. So which any number raised to the power of 0, which means that this one is 1, and we are having ax power 4. So this power 4 will affect them. We shall have here ax power 4. Now you come here, any number raised to the power of 1 is that number itself, and the sign here is negative. And when you see here you will have 4. When you open the power here, you will have ax cubed by times 4, which is this plus this negative 2. This is the same as having 4 times negative 2 into ax power 3. So which will give you negative 8 and open the bracket and the power of 8. This is the same as negative 8 ax power 3. And then we shall have here also, we are having ax power 2 times 8. Now this one we are having negative 2 power 2. So this is the same as having negative 2 times negative 2. Negative will neutralize to give positive, giving us positive 4. And 4, when you have 4 times 6, you have 24. So this one will give us positive plus 24 ax, the power is 2, plus this one is the same as having negative 2 times negative 2 times negative 2. This one will neutralize to give us positive times negative, positive times negative. This is
And increase the speed. Let your co-presenter you go and send you.
We apologize for inconvenience. My name is Otim Patrick from Barongo SS, a co-participant to the first presenter. You allow me to restart it again afresh. It was question 2. It the expansion of ax minus 2 power 4 multiplied by 1 bx in bracket power 3 is written in descending power of x. The first 3 terms of this expansion are this number given 21x power 4 plus 99.
You're wasting time. That's what they are saying.
That expression, that we can expand this one by one to avoid bulkiness of the work, may allow me start with this ax minus 2 power 4. I use passwords square 1, 2, 3. Then if we expand this for ax minus 2 power 4, we have ax power 4, the highest power negative 2 power 0 plus ax power 3, we are descending power 1 plus ax power 2 negative 2 power 2 plus ax power 1 x power 3 plus ax power 0 negative 2 power 4. And we have our coefficients here 1, 4, 6, 4, 1. That when we multiply this by the coefficients, n number to power 0 is just 1, and the coefficients is 1. We have a power 4, because the power affects everything in the bracket. Power 4. And this is now 4, the coefficient. This is affected by everything. Here we have negative 2, that's a negative 8. A2, x2. This one affects everything. There we have 4 plus 24 s square x square plus here we have negative 2 to power 2 is 8. 8 by 4 we have increase your voice. 8 by 4 we have 32. That's a negative 32 ax. Any number to power 0 is 1, we have plus 16. That's the expansion of the first bracket. And you have what px.
But you show that expansion, put it in there.
This is the expansion of the first bracket, and we have another bracket 1 plus. We can still expand it using the same formula. 1 power 3 b over x power 0. 1 power 2 b over x power 1. 1 power 1 b over x power 2 plus 1 power 0 b over x power 3. And we go to our Pascal's triangle and look for the square. Since we have power 3 as the highest, you take this as the coefficients 1, 3, 1. Then we have this n number to power 0 is 1. And this is now 1 plus this number 1 times this. We have 3b over x plus this 3b square over x square. Any number to power 0 is 1, and we have plus b2 over x 2 is an expansion of 1 plus b over x by 2, which is given by this expansion square over. And from here, we can multiply it. This expansion, where for this number, ax2 power 4, 1 plus b over x over 2. And the expansion of this, we got it down there as ax minus 8 ax power 3 plus 24 ax squared minus 32 ax plus 16 multiplied by what we got in the second bracket, which was 1 plus 3b over x plus 3b squared over x squared plus 3 plus b2 over x cubed. Close the brackets. Then here we multiply it all through, but to avoid valueless, we pick since the first number has the highest power, we multiply all through by the first number. That we take ax power 4, multiply by this one. Then this plus this same number, multiply by this number. That is b a power 4 b, but you know this x will reduce by this x, which is power 4. That means we have here now x power 3 minus our 8 a power 3 x power 3. So that we have power 3, the same number multiplied by this plus 3 a is a power 3. We are multiplying this number by the third number, that is 3b squared, that is 3a 4b squared, x power 2. Since here is power 4, 2x has crossed, minus 24 a power 2x power 2. And we are given just in the question first 3 terms. We can draw simple and multiply, but since we are given 3 terms, we can even stop careful. Here has given us 3 terms. I have a x power 4 plus 3a bx power 3 that I can pull up the common factors being 3x2, x2 into 3a power 4 b minus 8a power 3 plus x squared into 3a power 4 b squared minus 24 x squared being our expansion to this number. Our expansion for this that's below. But the question went ahead and asked us find the 3 terms. Given that in the question the 3 terms are as below. 81 x power 4 plus 99 x power 3 plus cx squared. That it is given a, b, c, a positive integers. We find the value of a, b, c. Now in finding the value of a, b, c, since these are the first 3 terms, we can compare the coefficients in the given equation ax power 4 plus 99 x cubed plus cx squared. That we compare the coefficients of this given expression, both sides, that could be equivalent to this. And we compare the coefficients. We start with x power 4. That x power 4 is given 81. X power 4, that we cannot even write it, and if just x power 4 is given as a, and we have got the value of a being 81. That means my value of a is 81. I compare the coefficients.
Excuse me.
X.
Yes, you excuse this, sir?
Yeah. Can you first go back 4 steps where you had a x power 4? Can you first go back a bit up where you had 1
x power 4?
Yes, you missed a 4 on
Yes.
a. You missed a 4 on a. Can you first place a 4 there? Ax, all of
There's
it
a power
power
4.
4.
Yes. Yes. Yeah, thank you, sir, for the correction.
Okay. Can we obtain the... Okay.
Yeah, thank you, sir, for the correction.
Now, since the coefficients of this, we are comparing coefficients of x power 4, that is this 84, that we can make this, if we break it further, like here, if we break a, when we break this 81 to power 4, I can have 3 power 4 is equal to a power 4. Three power 4 is equal to a power 4. Since we have the same power, that means 3 is equal to a. I can just need to write a is equal to b, and our answer is a is equal to b. Then I go further comparing the coefficients of x cubed that is given in this expression is given 999. 999 represent 3a power 4b minus 8 cubed as given below. And you know our a is 3. That's 3 into 3 power 4 times b as 8 into 3 power 3. When you press on a calculator, you know this is now 81. 9981b minus I'm sorry, 3 times 8, 1b minus here when you press on calculator is 216. Then when I press this on calculator, here is 243. Where we stop, we are 999 243b minus 216. You correct the right terms and we have b as b. It's 5. You take this side and divide all over by this. Then we compare coefficients of x power 2. That is given c is equal to 3a power 4b squared minus 24a squared. Now we know b and a given below our a is given above our a is 3 and b is 5. Now we can substitute them here, having a 3 power 4, b which is 5 power 2 minus 24 times 3 power 2. Our c is given by 607 5 minus 1944. When we subtract, we get our c as 4 1 3 1, and our c is therefore
That is 216. 24 times 2 minus 216. How are we getting? The phone has gone off. The phone has gone off. Are you saying you guys now have been, if you are not serious, you can.
Okay, I know. Yes, teacher Jimmy? Yeah, but for that last part, I do expect your C to be 3051. So you check out. I've also noted the answers I was seeing in the chat. I've also noticed the answers members are giving in the chat. Not so. Kindly check out that you have 3051. Your A is 3, your B is 5, and then the C is 3051. Okay, okay. Thank you so much. I know some of you have some questions. I'm going to start with Pakwachi. Yes, Pakwachi, you can unmute. Pakwachi, unmute. Okay. Pakwachi is failing to unmute. Nama SS Mitiana, you can unmute. Okay. Yes, Pakwachi.
Yes.
Pakwachi, ask.
So, for us, we would like to request, if at all you'd like us to discuss some of the numbers, number 9 and number 18.
Okay, we shall give you an opportunity. We shall give you an opportunity.
Okay.
Kaboda, and ask.
Thank you. Good afternoon, everyone. Now, our learners, they need to know something. Can you unmute, please? I mean, mute. Good. Mr. Kaziwa was like, this learners of ours need to be helped somewhere. The way they're moving, someone is having content, but the way the content is presented, sometimes you see that there's something missing. Like when you check, if we had not to go back to check on the other step, he was giving us A as 81. Yet he forgot that it was having a power 4. So learners, you need to be serious when you are doing mathematics. We need to have some speed, accuracy, and conscious as you are doing what you are trying to do. When you check on that number, our discussant were just looking at the expression given, but didn't go through the question to see that they were saying in a descending manner. What implies is that we are going in a reducing power. But for him to say, since you are seeing we have power 4, power 3, so let us look at that, which was not, I think, required. You are supposed to tell the fellow that the question is talking about discussing, we're going in a descending order, so that we can check one per one. Not that you see, no. Mr. Kazi, allow me to submit as for now as we continue with the discussion.
Okay, thank you so much, teacher, for the submission. Okay, then, okay, Lomo Moses.
Yes. Good afternoon, everyone. I think I have a question. And the question is value of A. And you see when you got 3 to power 4 is equal to 8 to power 4. I want you to clarify how the powers disappear.
I beg your pardon? Pardon?
The presenter was saying that since the powers are the same, just let A is equal to 3. I don't know how those powers disappeared. Then secondly, we would like to present question 18. I don't know if you can grant for us.
Okay, that is well noted. I'm going to ask, I think it is Coach SS to organize yourself. You are the next as we first conclude this part of. Now, dear participants, like the teacher has already informed us, please, having speed is very okay, but one mistake you make can cost you heavily. So make sure that apply the speed you think you are comfortable with, but as you are running through your work, go back and check through the steps, because you not just one mistake. Remember, I had AX everything power 4. Just him forgetting one term to be powered to 4, it was going to cost him the whole number. So make sure that you go back and review. For whatever step you go ahead, look through your previous step. For whatever step, look through the previous step. Then from there, start reasoning out. Does the answer that I've got make sense, or it does not make sense, before you go on to make a conclusion? However, speed will also come for those when you plan better. Make sure you plan better. And that's why we say what we call the 5 P's, that prior planning prevents poor performance. When you plan better, you are able to avoid many of the mistakes that would have come. And how do you plan? By doing quite a number of questions. Whenever you do a number daily, time comes when the errors you are making are minimized. Then our friend who asked us about a power 4 is equal to 81. Now, we know very well from your knowledge of indices that whenever I have a number to the same base, I can equate the powers. In case I have 8 power m is equal to 8 power n. An example is 2 to power 2 equals maybe to 2 to power x. Whenever the bases are the same, I can just equate the numbers. So that means 2 is equal to x. Similarly, whenever you have the same powers, you can easily equate the bases. So in case I have m and this is n, whenever the powers are the same, I can just equate the bases as long as the power are the same. So here you notice that 8 power 4 is equal to 81, but 81 is the same as 3 to power 4. Since the powers are the same, then it means I can just equate the bases. So a is equal to 3. Alternatively, you can introduce in the idea of log if you are well conversant with them, whereby now here I'll introduce logarithm on both sides. That one can as well work for you if it is very if they are very friendly to you. However, when you are dealing now with logarithm, introducing logarithm on both sides, then now you need to avoid having decimals such that you can be able to do it. That means that you can say when I have log a power 4 introduce log on both sides, this will be log of 81. So next you drop the power, so you have 4 log of a is equal to log of 81. Then remove the 4, remove the 4. After removing the 4, then you can go on and use this law of logarithm. A to power b is equal to c, which is the same as b equals to a power c. So you can use that one to be able to get that this one will be this will be 10 log of 81 out of 4, which will still give you a 3. So you can use that kind of approach if you want, in case you don't know how to express. But still, even dear students, if this number we had this side could not be prime factorized in this format, then we would have expected you to introduce the idea of log. You can as well, even if it is natural log, it can work as long as you know how to utilize it in order for you to be able to solve. So you can introduce natural log on both sides, but you use the approach that is very easy for you. But in case you need to go back and revise your logarithm on how to introduce. Another person still when it comes here, someone with a mathematical eye could introduce logarithm of base 4 on both sides. That one can as well work. But do not forget this concept here, because it would have been much easier for you. Remember that when I have, let me say, log of, let me say this is my log, then it means that here, this one comes here, and you have 3 equals to 2 to power 5. So you can use that idea in order for you to solve. So that is the idea you'd have applied here after removing 4, such that you get log of a equals to log of 81 out of 4. But you know that whenever we don't place a log, there is base 10 here. So that means that this 10 would have gone here and remain with a equals to 10, but everything log of 81 out of 4. Then you place in your calculator. That would have been the other alternative approach that you can use. Okay. So we are going to continue. I want to know, Coach SS, which device are you using? Coach, unmute. Coach, unmute. Coach, unmute. Am I failing to get Coach? When we fail to get Coach, we are going to go on and check and start with paper 2. Coach. Okay. Then add lang, as I check on add lang, kindly unmute, add lang. Oh, Nama SS, you can ask add lang, unmute. Sorry, add lang. Nama, you may ask your question. Yes, add lang.
So the question is about partial fractions.
Yes.
You took to the other case number 3 where the denominator may be quadratic. If that quadratic has the coefficients of A, B, and C, can I express it as the product of linear factors?
I beg your pardon, when
that quadratic has the coefficients of A, B, and C, can I express it as the product of its linear factors and use the other approach of case 1?
Now, if you are asked, okay, I didn't pick your question. Come again, clearly.
I think you are getting us now. The case 3 where the denominator of a function may have a quadratic. And if that quadratic has the coefficients
You are getting us
A,
now,
B,
clear?
and C, can I express it as a product of the linear factors and use the other approach of case 1?
Oh, yes, as long as the factors for that particular quadratic are linear, it is very okay. That's why always you first check
Have you
out.
reduced the volume there?
Okay, sir.
For today's case seminar, I'm presenting, you are presenting question number 2. No, not 2, question number 3. And question number 3 is taken from 3. I'm presenting A part, then one of my colleagues will present number 2. And for the A part, for the A part, the series that they're talking about AP. AP, that's the arithmetic progression. And in the arithmetic progression, we should know what? We should know that the first thing we should know A, which is the first term, and what next we know what is the common difference. And for this A part, we say that the first three terms of arithmetic progression are
question number. You read the question number?
okay. We are taking the question number. Question number 3. That is A. And it's talking about AP. And under AP, I said it's you know the first term and D is the common difference. And for this one, they say that the first three terms of arithmetic progression are the first one they say is lim P.
Then just support it the way.
Lim P for 4. Then we have one lim of P for 7. Now for this one, we should show that you get a common difference for this one. But a common difference, it means if you subtract this lim P from lim P for 4, you should get the same answer. And also the same answer for if you subtract what this one from this one. So our common difference will be lim P for 4 minus lim P, which should be equal to what? Lim of P for 7 minus lim of P for 4. And if you are happy with it, our answer is what? Lim of P for 3. So that is our common difference. And now for it, the continue with the question I'm saying, there where P is a positive constant, and the sum of n terms of our geometry of the progression is that. It means that given our Sn equals to our Sn is 4x 4 5 d of P. So since the teacher was emphasizing on the use of the mathematical group, so for me, I don't master this formula. So, but I use all the mathematical book. So let us see this formula from the mathematical book, and we see how we can manipulate this number and get the word of n. And the formula is there under what? Under algebra. From the mathematical book. So under algebra, formula number what? Formula number 7. We have the talking about AP, and the summation of AP is given by this one equals to n over 2 into 2a plus m minus 1 d. Now this is the formula for what? For summation of what? A GP, a series of GP. So no GP, AP. So for this case, now we are going to substitute our value. They are asking for the value of n. So your viewers, let us follow. So for this one, for this n, the value is already here. So we are going to substitute. This is 4a, 4, 5. Then we know p equals to this one n 2 into 2n. Now plus our n minus 1. Now our common difference is what? Is ln p over 3. So for this one, for this case, it remain ln p equals to this one will be n 2, n over 2. Then we shall enter this one inside 2a plus n n then of p q, then minus n of p q. Then now for this one, since this one and this one they are multiplying, we take this one that side. So our A is the first term. Oh, let us substitute for the first term. So A 4, 5 ln p equals to n over 2 into 2 times. Our A is the first term, which is what? Ln p. So put that ln p, then now plus n ln of p cube minus ln of p cube. Now for this one, we take this one this side, huh? So we press on the calculator 4, 8, 4, 5 times 2. It's 9,690. Ln p equals to, now for this case, let us multiply now all the root by n. Now this one will be 2n ln p, then plus n squared ln p cube, then what? minus n ln p cube. Now for this one, we are going to divide all through by what? By ln p. Ln p, ln p, and ln p. So if we divide this side, we shall be like this: 9, 6, 0 equals to. This one now we have what? 2n. Then for this one, we are going to have what? Ln p squared. Now minus n. This is 2 ln plus n squared ln p squared. Then become minus ln p squared. And so this one now, we are going to, this is a logarithmic subtraction. We are going to what? If two look in Java, they are subtracting in that, they are dividing. So that for this part, they are going to become given 2m plus now. Our m squared given p squared divided by m given p squared. So this one they go, this one to leave this one. So you will then get 9690 equals to 2m plus m. So you have 960 equals to 3m. Divide all through by 3, all through by 3. So this one we have 3,000m equals to 3,230. So this is our solution. So for the big part, another part will come.
Maybe questions for that part?
We can continue.
For part B.
We can continue, but don't flag off.
Open the video.
I'm saying we can continue. Yes, we can continue.
Okay, guys, let's continue with part 3 of question number 3. The first part was talking about AP, and the second part is talking about DP. So, our second part is saying that the first 3 terms of a geometric progression. So you know that it is a GP. So what you should know in a GP is a GP. What is key in a GP is a common difference, and the common difference common ratio, I mean, not difference. So in a GP, what is the key is the common ratio, and the common ratio is got by dividing the second term by the first term or the third term by the second term. So you should know that the common ratio should always be the same. So they are saying that the first 3 terms of a geometric progression are q to power 3x, q to power x, and q to power negative x, where q is a positive integer. Then they are saying that find the nth term of this progression, giving your answer in the form of q into q to power a plus bn x. So what you should know here is that the nth term un of a GP is got by a to power r, a to power ar to power n minus 1, where your a is the first term, your r is the common ratio. Then your n is now the number of the terms that you are going to get here. So they're saying that find the nth term. So your n is equals to a. But before we go to getting the nth term, let's first get the common ratio. So our r is equal to the second term divided by the first term. That is q to power x minus q divided by me. The hand is not right what the brain is saying, so you can understand that. So
by q to power 3x. This one should always be equals to q to power negative x divided by q to power x. Dividing this term by this one and this one by this one should always be for the same answer when they are handling series. So when you divide numbers of the same base, you just subtract the powers. Yeah? So when you subtract the power here, you'll get q to power x minus 3x, which you will get q to power negative 2x. So okay, let's also try to handle this one if it will give for you the same answer here. So we are having q to power negative x divided by q to power x. So as I told you before, when you are dividing numbers of the same base, it doesn't subtract the powers. So it is q to power negative x minus x. So negative x minus x, it will give you negative 2x. So it will be q to power negative 2x. So you can see that this one and this one are the same things. So we are good to go. Let's now find the nth term. So our un is now equals to a to power r to power n minus 1. So our a is q to power 3x times r. Our r is q to power negative 2x. Q to power negative 2x to power n minus 1. Are you getting? So this negative 2x here, this negative 2x here is still the power of r without putting the power of n minus 1. Let's not confuse that with the what we are working for. So it is the q to power 3x multiplied by q to power negative 2x, q to power negative 2xn. This negative will multiply this negative one, it will become positive plus 2x. So, as we know, when we are multiplying, when we are adding powers of the same base, it implies that we are multiplying. So this one is the okay. When we are multiplying numbers of the same base, we just add the powers. So this q and this q are the same thing. So we just keep the same base and we just add the powers. So this one implies that we shall have q to power 3x minus 2xn plus 2x. So we shall now have q to power 5x minus 2xn. So we shall now have q to power 5 minus 2n x when we factorize the x out. Yeah? So the question was saying that find the nth term of this progression, giving your answer in the form of q to power a plus bn x. So we have now expressed our expression in the form of, so this one is now in the form of q to power a plus bn x, where our a is equal to 5 and our b
is equal to -5. So that is where we are going to end with our presentation. If there are questions, you can forward them. So, as I said, this is where we are going to end with our presentation. If you have any question or if you have any challenge with the series, you can ask the question and we shall answer you appropriately.
Okay. Thank you so much. I just want to get a confirmation whether on part A,
Thank you so
we
much.
got our answer
I
as
just
n
want to
is
check
equal to
comments with
57.
one part A. Thank you so much for answer. I just want to check comments with one part A. Thank you so much for answer.
Yes.
Asking questions.
Yeah. No, the answer here is okay. The answer is okay. 5 minus 2n, all of it multiplied by x. I wanted to just get some clarification on part A whether we had our answers n is equal to 57. Did we get that answer? On part A, not this part. The presenter for part A, did we get our answers 57? I wanted to get some clarification from you. Yes? Presenter for coach. Did we get our answers n is equal to 57? Yes. Dear participants, kindly check. Our answer is n is equal to 57. Unfortunately, they labeled the board. Okay. Oh, coach, okay, coach. I've seen coach a minute. I've seen where the problem. Yes, coach, you can unmute. Coach, unmute. Coach, unmute. Coach is not unmuting.
So I said for the first numbers, we failed to what obey the law of logarithm. So I said I bet we have got just only like 2 minutes we shall be done with that number. So we are going to redo that number and see and we get the answer of feature 6 as the feature 7. So for the function, but if I say that we have our common difference, then our first term was what? Our first term it was what? Linear. Then we have our Sn equals to 4x45 ln of p. Then now for this one we use that means from over AP equals to n over 2 into 2n plus n1 then d. So for this one we are substituting n over 2 into 2 ln 3 plus our n minus 1, then we will be. So for this one, we are multiplying this on the b 96 96 0 9690 equals to 96. This one was 9,690 equal to this part. We are multiplying this one and go. So this one will be 2n ln of p, then plus this one multiply this one n square and this one multiply n square b square then minus this one and this one n ln of p. Now this one we are taking this one as a 4 ln p 4 9690 equals to we take this one as a 4. So it will be ln p and so plus this one and this one we multiply this one will be what ln of b n square. Then so this one will be minus ln of p n. Now we simplify this one. So this one will be ln p 9690 equals to ln of 2n times this one they are adding means we cannot multiply the 4. So this one will be 2n times n squared. So for the what? For the subtraction, we are going to put what? Division. So that this one is the n. So for this case now, the same place now we can put the powers. So this one we say 9690 equals to 2n times, I think this one we can multiply 6 n power 3 over 3n. So this one they can reduce. Yeah. This one we have 9690 equals to 2 n squared. Divide both sides the 2, get 4 5 4 5 equals to n squared. Then the root, get the root. N equals to is the 7. So, but we ignore the negative 1.
Okay. Okay. Thank you so much. Thank you so much. That is Coach Secondary School. Now I think it is very okay. So next, we are going to have Adlang Secondary School. Adlang.
Yeah.
Okay, wait. Wait. A minute. Can someone place the square root of Yes, it seems there is a problem again. That is just a minute. I'm trying to look through. Oh, okay. I'm trying to get where the problem is. I'm saying the 3n squared times the teacher. Can the student first check whether there's somewhere where he's having 2n? Was it 2n or 3n? Can we first check this last step down here, where you had ln p 2n 3n squared minus that minus 1? Was it 2n? There is a problem somewhere. I think there is a problem. The answer is not correct. Continue. Yes, there is a problem there. 3n, okay. Go up there also. Now, where there is 2n times 3n squared, that one is 3n. 3n down. Not really. The denominator is supposed to be 3n. There's a problem. Okay. What we are going to do, I'm going to post the solution in the chat here. I'm going to post the solution in the chat of that approach here. Yes. Yes. So there is a problem with the working, but we are going to. Yes, there is a problem with the working somewhere. Okay. So can we have Okay, let's give him time to figure it out. Okay. Okay, we are going to leave the question. We are going to leave the question. We shall come back to it. We are going to come back to it. So I will summarize it at once. Let's first have the Adlang. Adlang, unmute. Adlang. So,
Okay. Wait.
yes, Adlang.
Okay. Before is Patrick Opat is my name. From Manila Senior Secondary School, Nagano District. Ready to present question in trigonometry that is none other than number 18. Number 18. Let's start with part A. And the question reads, show that cos theta all over 1 plus sin theta, then plus 1 plus sin theta all over cos theta can be written in this format, can be written as, oh, yeah, is equal to 2 sec theta. Now, since the question is show that we shall start from the left hand side and we show that the left hand side is equal to the right hand side. Let us take this part. Yeah. So cos theta all over 1 plus sin theta, then plus 1 plus sine of theta all over cos theta is equal to, let us now try to summarize this one so that we come with a dense property like this one. Let's try to get the LCM of 1 plus sin theta, then cos theta, which is the same as cos theta, open the bracket, 1 plus sin theta. Let's now try to simplify these sides. Cos theta, this LCM when we divide by this one, we shall remain with this cos theta. And cos theta times this one, we shall get cos squared theta. Then this LCM and all of this times this cos theta will give us this one. Then we multiply 1 plus sin theta all over this and this term, which will be 1 plus sin theta, then 1 plus sin theta. We have now simplified this one previous step. Let us now go in the next step. Let's try to open this bracket. We shall remain cos square theta plus 1 times 1 is 1. Then 1 times sine theta is plus sine theta. Sine theta times 1 is okay. Sine theta plus 1 is plus sine theta. Then sine theta times sine theta is plus sine square theta all over cos theta, then 1 plus sine theta. Let's try to collect the like term. We shall have cos square theta plus sine square theta, then plus 1, then plus this one is the same as 2 sine theta all over cos theta 1 plus sine theta. But export this one bracket. We have the identity that says cos square theta plus sine square theta is the same as 1. Therefore, we are going to substitute for the value of cos theta plus sine theta. Cos theta, cos square theta plus sine square theta is 1. Then plus this one, then plus 2 sine theta. All over cos square theta. Okay, cos theta open bracket 1 plus sine of theta. Now this one is the same as 1 plus 1 is 2 plus 2 sine theta all over cos theta, then 1 plus sine theta. Let's now try to put the common factor from the numerator. And we shall have 2 outside, 1 plus sine theta. So that will, when we open this bracket, it brings us there. Then we shall have cos theta, then 1 plus sine of theta. This side, this bracket term, they can come, and we shall make it 2 all over cos theta, which is the same as 2 times 1 all over cos theta. And 1 all over cos theta is sec theta, which is 2 sec theta. Therefore, can say cos theta all over 1 plus sine theta plus 1 plus sine theta all over cos of theta is equal to 2 sec theta as required.
Okay. Okay, we are still unapplied. We are still unapplied on the three. So we shall go to question B. So now the DB, you have to show that sine 7 minus theta plus sine 7 theta plus 2 cos theta. So let us solve this. So if you look at this question, you can solve this question using two different methods. Next, maybe we can start with method 1. So in method 1, we are going to use what we call factor formula. So in method 1, let's use factor formula. Factor formula. So from factor formula, if you look at this one here, it is sine plus sine. So this one can be written in this form: sine A plus sine B. The identity using factor formula we shall get 2 sine A plus B, then cos A plus B. So we are going to compare. So if you have to compare this, we shall have A, which is equal to this 7 theta. This one will be our A. Then our B is going to be 207 theta. Then this one is we are going to substitute it here. So this one will be now 2 sine our A is this 207 minus theta as our B is this 207 plus theta. Then cos our A is this okay, I was forgetting this one you can divide by 2 and divide by 2. Even here the same, we divide by 2, I'm sorry for that, divide by 2. If I will pick 207 minus theta, then 207 plus theta, divide by 2. So let us continue. So from here, shall have to sine. So if you are open this bracket, we shall have 270 minus theta minus 270 theta over 2 cos 270 minus from the formula, it's around this one. Divide by 2. Then cos. Our cos is around 207 over 207. Yeah. Is what? Minus theta. Minus b is this 270 minus theta. So then it's over 2. So this one is allowed. If you have to open this bracket, it's allowed to sine. So let us open the bracket. It's allowed to theta plus 207 plus theta. Everything is over 2 cos 207 minus theta. Then this is minus 207 minus theta. Everything is over 2. So continue. So if you have to simplify this one, this is 207 plus 207 is allowed to sine of 207 plus, if you correct this right term, it's allowed 540. Then negative theta plus theta will go. Automatically, you will divide this by 2 cos. This cos 270 minus 207 is 0. Then we have negative cos. It's negative. Negative theta minus theta. Here is allowed negative theta. Over. Okay, it's negative 2 theta divided by 2, like that. So here is allowed. We have 2 sine of. If you divide 540, divide by 2, we have 207. 207 cos negative 2 theta divided by 2 and negative theta. So if you have to press on calculator, sine of 207 will have all this is negative 1. It's negative 1. Negative 1. So if you open this bracket, it's allowed negative 2 cos. Therefore, sine 7 plus theta plus sine 7 plus theta giving us x. So, I system become take pass. Okay, there's one thing that I want to emphasize.
someone might have not understood where this cos negative theta became cos theta. Remember from the trick, cosine, let me say cosine of negative 90 is the same as cosine of 90. And that is why cos of negative theta became cos theta. Thank you.
We are looking at C complex of this number, of which is giving us that we have to solve tan of x plus 5 out of 4 plus 5 out of 4 plus x, okay, plus 5 out of 4, which is equal to cos of x plus sin of x out of cos of x minus sin of x. We have to show that this one is equal to this. Now, if we are to see 5 is the same as 180 degrees. So we shall substitute 180 where there is 5, of which it's going to be tan of x plus 180 out of 4. Out of 4. This can give us tan of x plus 180 divided by 4, it is 45. It is 45. Now, the question is demanding us to show that this one is equal to that in terms of cos and sin. But from here, it is done. It means that this one also, we are also going to change it to be in terms of cos and sin. For this case, it's going to be sin of x plus 45 out of cos of x plus 45. Actually, this one now, we shall use compound angle formula, of which we shall get this one. The sin of x plus 45 is the same as sin of x. Is the same as sin of x cos of 45 plus sin of 45 cos of x. However, compound angle formula for cos, it says cos of x cos of 45. From here, it's saying that plus. And now for the cos, when it is plus, it changes to minus. And when it is minus, it changes to plus. Now for this case, this one also is going to change to what? To minus. Of which it will be minus sin. Sin of x, sin of 45. In this case, we shall use what is called trig ratios. Now, in trig ratios, for tan of 45 is tan of 45 is the same as 1. Now, the formula for tan is adjacent out of, it is the opposite out of the adjacent. It means that for us to get this 45, it means that our opposite is 1 and the adjacent is what? It is 1. Now, if we are to see from the tan of 45 in trig ratios, it means that our opposite is here, which is and the 1 is here. And then using the Pythagoras theory, we shall get root of 2 this side. And now we shall present this one in terms of cos and sin, of which our cos of 45 is going to be cos is adjacent out of hypotenuse. Now the adjacent from here it is 1, and the hypotenuse is what? It is root of 2. Even we have to get sine. Sine of 45 from here. Sine is opposite out of hypotenuse. Now the opposite of this one is 1, and the hypotenuse is root of 2. Even the sine of 45 is 1 out of root of 2. We come and substitute it in our working. Where there is voice, we shall substitute with this thing that is with the value that we got it from here. So it will be sine of x into 1 out of what? Root of 2 plus 1 out of root of 2 into cos of x. We divide it by cos of x into 1 out of root of 2 minus sine of x into 1 out of root of 2. From here, we shall pull out the common factor. And our common factor from this page, it is 1 out of root of 2. We shall pull it out. Or which it will be 1 out of root of 2, 1 out of root of 2 into bracket sine of x plus cos of x divided by, put out the common factor from here, it's 1 out of root of 2 into cos of x minus sine of x. This one and this one, they cancel. And when they cancel, we shall remain with sine of x plus cos of x. How of cos of x minus sine of x. Therefore, we conclude our answer by starting by stating what was mentioned for us to solve, which is tan of x plus 5 pound of 4, which is equal to sine of x plus cos of x out of cos of x minus sine of x as required.
Yes, ma'am. I'm going to answer. You saw that all of them they say so from here we are going to rearrange the trick in order to make it easy. To make it easy, so we are going to start from 5. Over cos of 5 plus cos of from here, we're going to move the decimal pattern. To enable us make it and to enable us make it for the function, we use the compound pattern and root pattern formula. So the angle pattern formula is say from sine, half sine, sine plus sine, we say sine of A plus B divided by 2 plus of A minus B divided by 2. So we are going to use this pattern formula to have a see these numbers. So we are going to pick the two numbers here. And from here, we have selected two numbers because 5 and sine 5 and sine delta. And then because 5 delta plus cos of delta. So from here, we are going to compare. This one will be our A, this one will be our B. And then for cos and cos, this one will be sine A plus sine B. Therefore, cos A plus cos B will be equal to 2 cos A plus B divided by 2 cos A minus B divided by 2. So we are going to apply it wherever to solve this one. So from the both sides, we're going to apply the formula. So this, we're going to pick this one and this one. So when we pick this first number, our sine 5 plus sine 5, sine 5 theta plus sine theta will be expressed 2 sine of 5 theta plus theta divided by 2 cos of 5 theta minus theta divided by 2 plus sine of theta divided by cos 5 theta divided by 2 cos of 5 theta minus theta divided by 2 plus this cos of theta. Oh, from here we are still okay. Yes, so from here, there will be 2 sine of 5 plus 1 will be 6 theta divided by 2 will get 3 theta cos of 5 minus 5 theta minus theta will be 4 divided by 2 will be 2 theta plus sine of 3 theta divided by 2 cos of 5 theta plus theta is 6. When you divide by 2, you get 3 theta. And then cos of 5 theta minus theta, you get 4 theta. Divide by 2, you get 2 theta plus 3 plus cos 3 theta. So from here, you're going to put the common factor. So our common factor from here will be sine of 3 theta. Because sine of 3 theta will appear in the reverse angle. So this one will be sine of 3 theta. When you pull out sine of 3 theta, you will be left with 2 cos of 2 theta plus 1 down. When you pull out cos of 3 theta, you remain with cos of 3 theta divided by. So when you pull out cos of 3 theta, you will be left with 2 cos of
together plus 1. So automatically, this is how to say it. So you come with it. So you will have sign out. Together. You will have sign out together. All of us. Together. So together. So sign divided by all. Automatically, we will go to sign out. Together. So this one. Therefore, our sign of theta plus sign of theta plus sign of phi theta divided by 4 theta plus 4 theta plus 4 phi theta. You can say that sign of theta. Now, theta as divided. So I'm just will mark the end of
Okay, this is where we are stopping for now. Maybe the next presentation can continue. Thank you so much.
Okay, thank you so much for that wonderful presentation at Lang Senior Secondary School, Dago. We are grateful to have you. I wanted to first have the teacher from Coach. Is the teacher from Coach on? I wanted to just find out. Just the teacher from Coach, are you on? You
Turn my video off.
Coach, have the video on. Teacher, are you on?
Yes.
Okay, you can have the camera on. Are we set? Okay, just give us a minute. Teacher, are we set?
We are set to go.
Okay. Okay, I think we can start. Though your camera is off, I don't know which camera you're going to use.
The network, my network.
Okay, I think I'm failing to get him clearly. Teacher Kaboda?
Yes, Mr. Kaziwa.
Okay, let me see whether I can see your board. Okay.
You can see my board?
Yes, I can see.
Let me try to use someone to hold it for me. Get from me the board. I want us to look at that number 3 part A, so that we clear that doubt together, then we move. When you check on our number, they say the common difference is N of P3, and the first term is N of P. When you check on the question, they wanted us to use sum of n term, which is s of n equals to n over 2, open bracket 2a plus open bracket n minus 1, then the common difference, then we close the bracket. But when you check in our query, we have the sum to anything term, which is 4, 8, 4, 5. N of P, is it? Then we are saying it is equal to the n term over 2 into 2. We pick our A. Our A is N of P. Then plus open bracket n minus 1. We pick our D, which is N of P power 3. I'll multiply these two both sides, which will reduce to 9690. Then N of P equals to, this 2 is not there now, we are going to have 2n N of P plus, I'm bringing this n here, which will be now n into n minus 1, N of P power 3.
Why is it so when there are two gadgets which are connected?
Now, what are we going to use? It is now the rules of indices. We are going to raise this, we raise this, we raise this. And that will give us N of P raised to 9690 is equivalent to or equal to, I raised to n. This will be now N of P raised to 2n plus N of P raised to now 3n into n minus 1. I think Mr. Kaziba, our learners can start from there to finish up the number.
Okay, thank you so much. Let me hope now everyone can be able to finish from there. So when you check out what we are remaining with, where we are, you'll note that you are going to form a quadratic equation. And when you solve that quadratic equation, you'll be able to get the n is equal to 57. Okay, thank you so much, Teacher
X
Kawada.
is capable. Then another will be x equals to negative 50 something. Let me confirm here what I got. Negative 56.6 something. So let them try. Sorry, we are using n. I use the calculator, that's now why. So let them try to confirm. If there's anything still, we can come in and chip in so that we move as a team.
Okay.
Allow me to submit.
Okay. Thank you. Thank you. Let me hope you can check coach. Yes. So okay. Yes. So yes. So there is that second approach coach has. I don't know whether coach you can as well unmute. Yes.
I did it. Yes, I think we are able now to clarify that if you follow all the procedures, we are able to get the factor here. And when you plug the input and also get and the energy
Get when you divide, you have to get two answers. Question, and get this, then you can but you shall consider a cost. This is your
Okay. Thank you so much, Coach, for that presentation. And thank you so much, Jacob. Okay. Next, Kangole Girls. Kangole Girls, we want now to... Okay. Okay, thank you so much. Kangole Girls, kindly let us know you wanted to make some presentation. But in case Kangole Girls, we wanted to start with you as you usher us into paper 2. Kangole, unmute. All the way from Karamoja. Kangole Girls.
Yeah, good afternoon.
Good
This is
afternoon.
Palabekese, so I'm just requesting, at what time do you think the other schools are going to present? Because I think time is also going, and then some of the participants are not yet presented. Is maybe having time or no? Thank you.
Okay, Teacher Komakesh, before you leave, which number are you going to present?
Number 16.
Number
and 17.
Okay, let's have you present as we get Kangole come on board.
All right.
Kangole gets to us.
You couldn't. Let me get it set.
Okay. Schools that have prepared for item 2, kindly put the item you're doing in the chat.
I'm requesting if could be given something like 10 minutes because since it is lunchtime, most of the students are already gone for lunch. So maybe in the next 20 minutes, they'll be back. So if schools are ready, they may start as we wait for the student to come back from lunch.
Okay, let's have Paida. Paida, kindly have your hand raised. Paida? Okay, I'm failing to get Paida as well. Paida? Okay, I'm not getting Paida very well. Okay, Sir Samuel Baker. Unmute. Sir Samuel Baker. Sir Samuel Baker, I can't hear you. Unmute Sir Samuel Baker. Talk. Okay, I'm failing to get Sir Samuel Baker. Yet you are on. Okay, but as we get okay. Yeah, but I want to also let you know. Okay, I think this is the techno I wanted. Yes, Kangolo, kind of unmute techno.
Now this is Paida.
Okay, yes, Paida.
Yeah, the students have yet gone for lunch. Maybe some 10 minutes they will be back.
Okay, okay. Okay, Paida. Okay. Okay, elucid SS. Kindly unmute.
Yes, thank you. We are ready, but we're going to use another device.
Okay, which device?
The CSS presenter.
Who? Elucid? Presenter. Okay, kindly have that camera on. For elucid presenter.
Then you unmute.
Now with the presenter.
Yes, good afternoon, everyone. This is Mongo Jakesazada from the Lucy Secondary School, maybe. Coming to present question 41. It is about differential equation. And we are going to start with the A part, which is saying form. The A part is saying form a differential equation for the temperature of the body. So we are going to say for number 41, A part, we are going to say let theta be the temperature of the body. Now, in the question, they are saying the rate at which the temperature of the body falls is proportional to the difference between the temperature of the body and its surrounding. So we are going to say that the theta, the T, is proportional to the difference between the temperature of the body and the temperature of the surrounding. Then we say it is alpha. So alpha is the temperature of the surrounding. And now we are going to introduce the constant of proportionality. And in the question, they are saying that the temperature of the surrounding is 15 degrees Celsius. We are going to say, therefore, alpha equals to 15 degrees Celsius. Now from here, we are going to set the theta, the T, equals to, and we introduce a constant of proportionality. That is negative K into theta minus the alpha, which is 15. And we are introducing negative because they are saying the rate at which the temperature of the body falls. So if it is a fall, that is when now we introduce the negative sign to the constant of proportionality. So this one becomes now the differential equation for the A part S as. This is the differential equation. So this is the differential equation for A part. And they continued in the B part, saying that determine time it takes for the temperature of the body to reach 40 degrees Celsius. But in our original statement given, they're saying that
the rate at which the temperature of the body falls is proportional to the difference between the temperature of the body and that of its surrounding. Initially, the temperature of the body is 80 degrees Celsius. So for B part, we are going to start here, where they're saying initially, the temperature of the body is 80 degrees Celsius, meaning at this moment, time is 0. And the temperature of the body, that is theta, equals to 80 degrees Celsius, and our time here is in minutes. So now we are going to substitute these two variables into our equation we got in A bar. So we shall now say the theta dt equals to our negative k into theta minus 15. Minus 15. And our theta in this case is 80. So we shall have now our theta over dt equals to minus k into 80 minus 15. Now from here we are going to find t. We are going to find t by now taking t the other side and bringing back the theta to this other side. Or maybe from this point. We are going to now have from the theta over the t equals to negative k into theta minus 15. From here, we are going to bring the theta to the theta, then we take the t the other side. So we shall have now the theta. When we bring this one here, we shall divide it. This side, if we divide it, we shall divide it this side also, meaning it will be over theta minus 15 equals to, and this side we are multiplying the theta. So the t, meaning this side also we shall multiply the t. So we shall have negative k dt. Now in this case, we shall now integrate both sides. We shall integrate both sides. Side that now we are having here the integral of 1 over theta minus 15 the theta equals to, when we integrate here, this one will cancel and we shall have negative k. When we integrate 1 with respect to t, we shall get t. So meaning we shall have negative kt plus the constant of integration. And this side, when we integrate, we shall find the natural log of theta minus 15 equals to negative kt plus the constant of integration. Now from here, we shall come and put in our value as, and they say at the initial position, initially, t is 0 minutes, and our theta equals to 80 degrees Celsius. Now we substitute these variables in this other equation. We shall now say natural log of 80 minus 15 equals to negative k times our 0, which is the time, plus the constant of integration. So now when we are having 80 minus 15, so we are having 80 minus 15. So we get there 65. So we shall have here natural log of 65 equals to, when we multiply negative k times 0, get a 0. Meaning this side we shall be left with c. Meaning our c equals to the natural log of 65. Then from there we come and substitute c in this equation. This one now will imply that our natural log of theta minus 15 will be equal to negative k t plus the c, which is the natural log of 65. That one is for that case in the first equation. Now they continued and say in B, where we have in B in the question,
They're saying determine the time. Sorry, from the upper question, they're saying initially the temperature of the body is 80 degrees Celsius. That is what we have done, which is here. They continue and say after 10 minutes, meaning now after 10 minutes, therefore our time will be 10 minutes. After 10 minutes, the temperature of the body is 60, meaning our data will be 60 degrees Celsius. Now we shall take these variables and substitute them in this other equation that we are having as natural log of theta minus 15 equals to negative k into our t. In this case, our t is 10 plus our speed, which is the natural log of 65. And here, our theta in this case is 60. So when we subtract 15 from 60, we shall get that the natural log of 45 equals to negative 10k plus natural log of 65. So we shall take this natural log of 65 and bring it this side. So we shall have natural log of 45 minus natural log of 65 equals to negative 10k. Now when we are subtracting the natural logarithm, so we shall have in this case natural log of 45 out of 65 equals to negative 10k. So we are going to find k by dividing both sides by negative 10. By negative 10. So our k in this case shall be equal to negative 1 out of 10 natural log of 45 out of 60 out of 65. Then we come and substitute k where we are having this equation. So we shall take now our natural log of theta minus 15 equals to negative k. And in this case, k is negative 1 out of 10. This other negative will neutralize this negative to give us positive. So we shall have 1 out of 10 natural log of 45 out of 65. And in this case, we shall have our t there, which is here. So plus the natural log of 65, which is the c, and it is here. Now from here, we are going to continue with our question. That is the real big part, what is asked there. They are saying, determine the time it takes for the temperature of the body to reach 40 degrees Celsius. So here the time is not given. They have given us theta equals to, we have to find t when theta equals to 40 degrees Celsius. So we are going to substitute these values in this other equation now. We are going to have now natural log of 40 minus 15 equals to 1 out of 10 natural log of 45 divided by 65 t. Because our t is not there, that is what we are finding. Then plus the natural log of 65. Now from here we shall have natural log of 25 when we subtract 40 minus 15 equals to, or maybe we bring natural log of 65 this side, it becomes now negative natural log of 65 equals to 1 out of 10 natural log of 45 out of 65. Then the t. You give the final value of t now. So now from here now we shall have natural log of 25 over 65 divided by, since we want t, we shall now divide this one by 1 out of 10 natural log of 45 out of 65 equals to t. So we shall have 10 natural log of 25 over 65 divided by the natural log of 45 out of 65. equals to T. So our T shall be equals to when we press this one from the calculator, we shall now have, let's give the answer. We shall have our T equals to 25.984 98441815. So therefore, since it is in time, we shall now round off the other number, the whole number. So we shall have 26 minutes. So meaning it will take 26 minutes to reach for the temperature to fall up to 40 degrees Celsius. So that is all that is required for that number. That is where I'm stopping for now.
Thank you so much, Elusi SS, and thank you so much for that presentation. In case we have questions, we can raise them, dear participants. Okay, the first one, Amugu SS. You may ask, and Aisha Girls, you may ask. Unmute. Aisha Girls, go on.
So my question is, there where the presenter written K is equal to -1/10 ln of 45/65. Why didn't he first evaluate it and find the value of K, then you continue? Because I'm seeing the work is becoming more congested.
So from where K equals to -1/10, from the value from where we started, where we had the theta over the T is proportional to theta minus So from here now, since K was negative there, we are going to just multiply this one with -1 times -1, which will give us a +1/10 natural log of 5/65. This is down.
Okay. I think the question the girl had asked was, what if you had just punched in the calculator the natural log of 45/65 times 1/10 and had your value of K, instead of carrying along with you the natural log of 45/65 in the calculation? So that she's asking,
Okay, so
why did you carry it?
we have taken note of that. Yeah, that is the question I was telling him also, but also in the interest of time.
Okay.
But we have got it. We have got it.
Okay.
The question. Okay, thank you. Maybe other question? If not there, we can end here.
Okay. Aisha Girls? Sir Samuel Baker? Okay. I think the questions are done.
Okay, thank you, sir.
Okay, thank you so much, Elus SS. But dear participants, in case you make your decision to have the value of K, make sure you write it to at least 4 decimal places such that the errors are minimized. Make sure that you write to at least 4 decimal places such that the errors are minimized. Otherwise, the format he has continued with guarantees us accuracy. Yes, but in case you do not know how to deal with those lanes, better you place your value of K and then continue. But make sure at least you have 4 decimal places such that the errors are less. Okay, Kangole, Gauss, unmute. Oh, I'm failing to get Kangole. Kangole, unmute. Hello, Kangole girls.
Okay. This is Kamala Girls Senior Secondary School. Good afternoon, everyone. I'm presenting question 30, paper 2.
Okay, kindly have your camera on. Okay, which district? Kangole?
Napak district in Karamoja region.
Okay. 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 Teacher, let's now focus on the chat very well, such that we can be able to see.
Let's try to correct some things in a short while.
Okay. So schools, we can open our seminar questions. They want to present number 30. Number 30, which is about interpolation and extrapolation. That is the idea. So let's give them just a few minutes and they get ready. Yes. So, but I would like to let you know, tomorrow we shall still be here at 2 p.m. Okay. We can start.
Okay. Question number 30 reads, the table values of tan theta have been extracted from 4 figure tables. And here is the table. This one is for theta. This is tan of theta. And the first one, we have 75. We have 76. We have 77. We have 78. And finally 79. Under tan of theta, we have 3.7321. Under 76, we have 4.0108. Under 77, we have 4.3315. Under 78, we have 4.7046. Under 79, we have 5.1446. And our question is estimate tan inverse of 4.6500. This is Roman number 1. When we look at our question, the tan inverse of 4.6500 lies between 4.3315 and 4.7046. And we extract our values from the table. From 77, we are looking for the tan inverse, which is theta. We can let it be theta. And then the next is 78. This is 4.3315. This is 4.6500. And this is 4.7046. This is our table. When we apply the gradient concept, which states y2 minus y1 over x2 minus x1 equals ya minus y1 over XA minus X1. According to our table, X1 is here, XA is here, X2 is here, and Y1 is here, YA, then Y2. Our question requires us to get the value of theta using interpolation. When we substitute our values according to the respective letters given, Y2 is 4.7046 minus Y1, which is 4.3315, over X2 is 78 minus X1, which is 77, equaling to YA is 4.6500 minus Y1, which is 4.3315, over XA is theta minus X1, which is 77. We reset our calculator. When we enter our values, 4.7046 minus 4.3315, we get 0.3731 over 78 minus 77 is 1, equal to 4.6500 minus 4.3315, we get 0.3185 over theta minus 77. When we cross multiply, we shall have 0.3731 into theta minus 77, equaling to 0.3185. And when we open our bracket, we shall have 0.3731 theta minus, when you multiply 0.3731 times 77, we get 28.7287, equaling to 0.3185. And then from here, we are supposed to collect the like terms. We shall take this negative 28.7287 to the other side, and it becomes a positive. Shall have 0.3731 theta, equaling to, when we take the other side, we have 29.0472. For us to get the value of theta, we divide by 0.371 on both sides. Our theta is 29.0472 divided by 0.3731. We have 77.85, but our angles are always recorded to one decimal place, and we shall have theta is 77.9 degrees. That is Roman number 1. Roman number 2, we are supposed to estimate tan of 79 degrees, 36 minutes. The way we read this number, it is 79 degrees, 31 minutes. And for us to convert this value into an angle into degrees, 1 degree is the same as 60 minutes. Here we have 60 minutes is the same as 1 degree. Now we have here 36 minutes. For us to get the degrees, we shall divide 36 by 60, and we shall get, we go back to our calculator, 36 divided by 60, we have 0.6 degrees. And now here we have tan of 79 degrees and 0.6 degrees. For us to get one value, we are going to add 79 degrees plus 0.6 degrees, and we shall have 79.6 degrees. Then from here, finally, our Roman number 2, because we have got the correct value, we are going to get tan of 79 0.6 degrees. From our table, 79 degrees is the other side, and therefore we are going to use extrapolation. And our table is this thing. So from our table, we are going to have 78, we are going to have 79 and 79.6, our value that we have got. And under that, we have 4 points. Under 78, we have 4.7046. Under 79, we have 5.1446. And here we are supposed to get the turn of this. We can represent it by any letter. Let's say Y. And according to the gradient concept, Y2 minus Y1 over X2 minus X1 equaling to YA minus Y2 over XA minus X2. This is our X1, our X2, and our XA. This is our Y1, our Y2, and our YA. So we come and substitute the values. Y2 is 5.1446 minus our Y1 is 4.7046 all over our X2 is 79 minus our X1 is 78 equaling to our Y1 is Y, our YA is Y minus the Y2 which is 5.1446 all over our XA is what? 79.6 minus 79. When we come to get the difference, 5.1446 minus 4.7046. 5.1446 minus 4.7046 shall have 0.44 all over 1 equaling to Y minus 5.1446 all over 0.6. When we cross multiply, we shall have Y minus 5.1446 equaling to, when we multiply 0.44 times 0.6, we shall have 0.264. For us to get our Y, we shall bring this the other side and it will be 0.264 plus 1446, and we shall have 5.4086. That is our turn of 79.6 degrees, which was initially turn of 79 degrees 36 minutes. I think I can end there. For any questions, please, I am available.
Okay, thank you so much, presenter. Okay, let me ask anyone with a question. Anyone with a question? Okay, presenter, from the chat, people are just, okay, there is one. Aisha Gauss, is it a question?
Thank you, the presenter, for the nice presentation. I would like you to help me and repeat where you got turn of 79.6. I have not understood there.
Okay. From our Roman 2, it says estimate the turn of 79 degrees 36 minutes. Let me now teach the illiterate. I think your teacher didn't tell you more about this. The way we read this, it is turn of 79 36 degrees. But we cannot get the turn of this because it is a mixture of what? Of trigonometry. And for us to get one number in degrees, it is 60 minutes equaling to 1 degree. And here we are given 36 minutes. For us to get the value of the degrees in that 36 minutes, we are going to divide the minutes given by 60 minutes for us to get the degrees in those minutes of 36. That is why I came to get 79.6. I got the value of 36 minutes as 0.6 degrees after converting into degrees. And after that, I added to the degrees given 79 degrees. I added plus the what? 0.6 degrees I got from the value of 36 minutes. That's how I came to get 79.6 degrees. Then I went on with my work to get the tan of 79.6 degrees.
Okay, thank you. Yes, thank you so much. I will request the teacher. I don't know whether you have some students in the room. You can at least turn and we have a look. Okay, okay. Okay, perfect. You can wave to ask people. Okay.
Yes,
Yes.
student.
Okay, thank you so much. Kangole, we are happy to have you. Okay, that is very nice. Thank you so much, presenter, and thank you so much. Okay, so next, we are going to have another presentation. We are going to have one more presentation. Okay.
Yeah, from
So
Kangole.
St. Charles. Oh, Kangole, you have another presentation?
Yes, sir. Yes.
Okay. Okay. Okay.
Just continue.
Okay. Okay, I'm presenting number 31, which reads, okay, my name is Nakiru Mary. I'm presenting question number 31, which reads, use Newton-Raphson formula to show that the sixth root of a number n is given by xn plus 1 equals to 5/6 into xn plus n over 5x power 5n. And the question says, draw a flow chart that reads n and the initial approximation x naught. So then Roman 2 says, computes and prints the roots to 3 decimal places. And then Roman 3 says, prints the n and the root. Then C part says, taking n equals to 30.5 and x naught equals to 1.2, perform a dry run for the flow chart. So we are going to start with B. A part does. Okay, A part which says show that. A part says using Newton-Raphson formula, show that the sixth root of n is given by this one. So let the sixth root, which is n, equals to x into 1 out of 6. Then okay, sorry. This x equals to n into 1 out of 6. And then now we introduce the what? We are going to remove x. So we shall say we have to remove by 6 by 6. So this one we shall be having x power 6 6. Then we shall say x power 6 minus n equals to 0. And then now we are going to say fx equals to x power 6n minus n. Then now we are going to differentiate fx is equal to x power 6 minus n. So when we differentiate, shall be having xn equals to, say, 6x power 5 power 5. So now we are going to show that so we are going to say our xn plus 1 equals to xn minus f of x into f of, but this one is supposed to be xn. Then now we introduce say xn plus 1 equals to xn minus our f of x is 6. It is x n power 6, okay? Not 6. Minus n over 6x power 5n. So now, which is now we get the LCM of this one, which is xn into 6xn power 5 minus into bracket x n power 6 minus n 6x over 6x power 5n. So when we open the bracket, we say this one is 6x power 6n minus xn power 6. This one will affect, this negative will affect this one, and it will become plus n over 6x power 5n. But our question is like, we show that 5 over 6 into xn plus n into over 5x power 5n. So we are going to pull out. We are first going to subtract this one will become 5x power 6n minus plus n over 6x power 5n. So we are going to pull out 5 over 6, okay? Which is you can even first separate these ones. First say 5x power 6n over 6x power 5n plus n over 6x power 5n. Then now we pull out 5 over 6, which is equal to 5 over 6 into, when we pull out 6, but before we pull out this one, we'll go with this one, yes? Then it remains 1x there, which is xn plus, this one is n over, when we pull out 5 over 6, this 5 over 6 was not here, so it is going to affect this one, meaning we shall remain with the 5x power 5n. So shall be having 5x power 5n. Hence, we have proved that one now. So we are going to question B. Question B says, draw a flow chart that reads n and the initial approximation x naught. So then now we shall be having our flow chart, which is says we start with the start, and when we are starting, we use the what? The circle. The start. Then we go to what? The next one for n. N equals to 0. Then we go again to another one for n is equal to our n equals to n plus 1. So from there we are going to the next one, next step, which says we are going to read, okay? We are reading n and x naught, okay? Then now from this one, we are going to the what? To the decision stage. No, to the assignment stage, which is xn plus 1 equals to 5 over 6 into 2xn plus n over 5xn power 5. Then from here, we are going to the decision stage. We are going to the decision stage. The decision stage, I say, is this one, is xn plus 1 minus x naught less or equals to 0.0005. Why we are putting 0.005? Because the question is telling us to compute and print the roots to 3 decimal places. So if it is no, if it is no, we are going to add to continue. We are going to continue from here. So we have this one, which is the loop of n equals to xn, okay? Then the other loop shall be having xn equals to xn plus 1. Then we come back here. So, but when you're doing, you can be using the ruler. Like this. Then this is if this no. Then if this yes, let's continue the other side. If this yes, we shall print out. Shall say print, okay? Shall put the print. Shall say print. You are printing what? N. Then we stop. We stop. So we are done with our dry run. Well, we are done with the flow chart. Then now the next question is compute and print the roots to 3 decimal places. We are done with that one. And the other one is taking n equals to 30.5. Our n equals to 30.5. And x naught equals to 1.2. They are saying perform a dry run for the flow chart. We are going now to perform the dry run. And in our dry run, shall be having n, xn shall be having xn plus 1. Then xn plus 1 minus xn like that. So from here, so from here, we are going to use our flow chart for performing a dry run. From the initial value for n is 0. So it is 0. Then now we are going to enter we are going to enter our values, which is the initial one is 1.2 as it is given from here. X naught is 1.2. Because if we say 0 plus what? This n is where it's supposed to be here. The 0, we are going to put it there. And then now we enter this one into this one. So we shall use the calculator. 5/6 into x plus our n is 30.5 plus into 5 of x power 5. Then we say calc. Then we enter. Our first value is 1.2. So we get 3.0429. So when we say, and after this one, we subtract. When we subtract to get this value, we shall get 1.8429. Then we ask ourselves, is 1.8429 less than 0.005? It is not. We go back where and we perform again. Then we say the initial value again will become what? 0.3. But from here our n is equal to n plus 1. which is, when we say 0 plus 1, it is 1. Then we say our initial value is 0.0429. Then now we say, we enter this one still, 3, we still enter, we get the book I was using. So when we enter, we get 2.552. Yeah, we get 2.5552. Then now again, we subtract this one from here, we get, when we subtract, we get 0.4877. Then again, you ask, is this less than the other one? If it is not less, you go again to the next step. Then you enter this one again. This one will become our initial value, 2.552. Then we enter and we get 2.1760. When we subtract, we get 0.3792. Then again, we have not gotten. So meaning we are going to say again, this one is our initial value. Then when we enter again, we shall get 1.9175. Then when we subtract this one, 1.9175 from 2.1760, we shall get 0.2585. This one is still not less than 0.005. So we shall go again to the next step. And we shall get, when we enter, I'll say this one is our initial value, which is 1.9175. So from there, we shall get our answer as 1.7940. Then when we subtract, we still get 0. Follow you subtract. 1, 2, 3. 5. Then again, we shall use these very ones. 1.7940. Then when we enter also this one to the calculator, we shall get 1.797685. Then when we subtract, we get 0.0255. Then it is still shall go to the next one, which is 1.7685. When we press it, we get 1.7685. When we subtract, we get 0.0000, meaning this one is less than 0.555. So we are done with that one. Then now we are going to print n. I say print n. Our n will be 1.7685. 8.5. And we stop there. Thank you for listening. In case there is any other question, you can ask.
Okay, thank you. Okay, any questions? Okay.
Hello.
Pakwachi, secondary, you may ask.
Okay.
Hello.
Please, could you explain for us how to construct the flowchart for you had some technical problem with our machine?
Okay.
I beg for your pardon. I didn't get what you're asking for.
Asking for that you, if possible, you explain for us how to construct the flowchart for we had some technical problem with our machine.
Okay. When you're performing the flow chart, we always start with the start, and then we use the circle for starting. Like for example, we have used this one, this circle. We are saying start from here. Then after the start, we are going to the next one, which we are going to use the what? The triangle and the rectangle. I mean.
Okay, let me pardon from here. When we are constructing a flow chart, the first is a circle, which is start. Then the second is for the initial value that they have given. And now our n is what? It is 0. You go to the next, which is what? Which is the read stage. In this case, you're going to what? You're going to draw what? A parallelogram, which is read. And you read what they have given from the question. And from the question they have given us n and x naught, which is what? The initial value. So we are going to the next, which is what? A rectangle. And it is what? Assignment stage. From here, you're going to copy what you've proved. The formula that they've given you from the question. I want the question paper. So they have given us the formula as xn plus 1. That is from the Newton-Raphson's formula. You're going to enter that formula in that rectangle. And then now after that, you're going to what? Decision stage. And that is, you're going to get this by saying is what they have given you, xn plus 1 minus xn less or equals to 0.0005. And this 0.0005 is got from where? From the number of decimal places that they have given us. So from here, what you're going to do is, in order to get this 0.0005, you're going to say 1.0 times 10 to power negative 3. After you entering that, then you multiply it by what? 0.5 in order to get the what? 0.005. Then, if it is yes, you're going to print. And if it is no, you'll go back. And from there, you're going to what? To the loop stage. And that loop stage, it is given as n equals to n which is n plus 1. And then you go to the next, which is xn equals to xn plus 1. This xn, we are going to get it from the formula. This xn plus 1, when you're entering this value of xn, which is what? The initial value that they have given from what? From the question. So you're going to enter in the formula, and then you come and what? Ask again the formula. Is xn minus xn, this less or equals to 0.0005. This magnitude of xn plus 1 minus xn is got from where? I can show you from the what? When you're performing from the dry run. This one here, which is xn plus 1 minus xn. You will ask yourself if it is less or equals to this number of what? The decimal places. And if it is not, you still continue. You go back. But what you have got from here, from the xn plus 1 after entering the what? The initial value of xn, which is what? Which is 1.2. After you realizing that it is what? It is no. You're going to use the initial value, which is 3.0429. You come back, and then you go back and you enter this into the formula in order to get this. You subtract again. You subtract this from this. Then this magnitude will remove the negative that you're going to get. I'm sure if you subtract this from this, you'll get a negative, but the magnitude will what? It will remove. And you'll ask again yourself if it is what? Less or equals to 0.0005. You continue until you get the final answer. Thank you.
Okay, thank you so much. Thank you so much. Kang.
Done well, eh? So you after here you sit down, get more example of that type. You do before you go home.
Okay, thank you so much for the presentation. Maybe I'm not saying that I think some schools have not yet maybe looked at the flow chart, and maybe allow me to just throw some little light. Now, a flow chart is more or less like how we do our activities when you're at home. That I'll wake up in the morning, have my prayers, then from the prayers, I maybe bathe. After showering, I go for breakfast, like that. So a flow chart shows us the steps in order for us to be able to reach a given output. Now, there are mainly four symbols that we use. And one of the symbol is the one for start and the one for stop instructions. Now, for starting and stopping instructions, we mainly use this oval shape. When it comes to reading and printing, when you are reading or printing or instructions, then we use this shape of this nature. Then when it comes to computation, when you are computing, we use what we call a computation box. And that one will look like this, to be a rectangle. Then when it comes to decision making, when you are making a decision, the decision box will always look like that. So those are the major shapes that we use when we are making. And they are very key when you are being told to draw a flow chart for a given thing. Secondly, when you are dealing with this flow chart, you need to know how each of those symbols are connected. Arrows are very key. So whenever you are drawing your flow chart, pay attention to the shapes you are using. After paying attention to the shapes, please go on and look at the arrows, the directions that your arrows are going, because they are very key, because they tell us the sequence, they show us the flow. But also when we are dealing with the flowcharts, please, you must know how to compute the error bound, but also you must be able to tell the purpose of the flowchart. Sometimes you may be asked to give the purpose of the flowchart depending on the formula you are dealing with. So we expect to know that when you are stating the purpose, you will say the purpose is to compute the sixth root of a number n. The purpose is to do this and this, but also I request you that after getting your final answer, you can verify your answer whether it is close or it is the same with that particular one. Take an example in case it comes to the sixth root and you punch in that given value that they have told you for n. Does it give you the value? So you must make sure you have it. So I expect you to tell us that when I'm starting my day, I will start with this shape. So this is the one for starting, that I will start my day with a word of prayer. Then you go on and tell us what next. So you tell us, maybe I'm going to write, so we expect that your flow chart will flow in this format, whereby you need to read some numbers. So this is read your n, maybe x, this is your x naught. Then from there, you can tell us the computation you are going to make. So here, this is where you put the formula that maybe xn plus 1 is equal to, you give us the formula here. So this is mainly for the formula you are going to use to compute. Then from the formula, you can now make a decision depending on the formula you have used. Then from the decision, we expect to go on and now do the printing, and then the printing you stop. But in case this is the formula, this is the decision. In case it does not work, then you go back. So in case it is no, then you have to go back, increase on the number of n, maybe n plus 1. Then from there, it means that also you'll have here your x of n equaling to xn plus 1, and then you go back to your formula here. So, okay, I've drawn it. It may not fit. So we expect you to have these arrows to show us the direction that you are taking. So please make sure you master very well the flowchart. Sometimes it may be given to you when it has been drawn and dismantled, and they may want you to arrange it. Sometimes they may ask you to draw it. So please interact with both on how to arrange it, but also on how to draw it. But also when it comes to computation, in case they give you that 5 to 5 decimal places, when you are making your computation, let the number of decimal places, the number of numbers that are coming, let them be more. Don't use exactly 5. In case they tell you to 3 decimal places, when you are making your computation, you are finding your values for n and the rest of that, please make sure that the values you are obtaining for xn plus 1 are having decimal places more than your actual value that they want you to round off to. So in case you are finding x plus 1, we expect that here the number of decimal places you are going to get for your xn plus 1 and the rest, let's have at least, in case they tell you 3, for you write to more than 3. That can be 4, 5, 6, such that at the end of the day, you are very close to the accurate value. I've told you always avoid approximating before you reach the final answer. Sometimes even they may tell you that write it to a given number of significant figures, so you need to be very sure on what to do for such cases. In case it's significant figures, you need to know how to deal with them and how to tell that this particular number has this number of significant figures. Okay, now
Mr. Kaziba, that presenter did not print the root. She only printed n, the number, but she should have printed n, comma xn plus 1.
Okay. Kagole, can you print for us everything? I don't know that Kagole can come back.
In the flow chart, she missed showing that she's printing n, the xn plus 1.
Okay. Yeah, let me hope she has taken note of it. So Dear students, do not forget on the printing. Okay, thank you so much, Mr. Ronald. But I know we shall make some clear guidelines, but also we shall share with you everything. Okay, we are going to have Mr. Komakech. Komakech, I wanted Parabek Secondary. Parabek, are you able to unmute? Parabek, unmute. Parabek, Mr. Komakesh Danish. Unmute.
Yes. So for the case is going to present number 13, 17, and 18.
Okay, so I'm going to request teacher that we present just one number and then we reserve the rest of the numbers for tomorrow.
All right. We're going by number 16, paper 1. 16, paper 1.
16. Did you have any for paper 2?
Number 4.
Number 4 of paper 2?
Yes.
Okay. Let's have that one.
All right. What's on the light? It's actually. Who is presenting? We said 10 here. Look where the question is. Numbers, let's careful. Yes. Start. Wait, you continue. Wait the question.
My name is Daniel. I'm a student from Finance NCSC. I will present the number for paper 2. Classification phase. The pattern projected from a point on the level ground. Such that its initial velocity
Reduce the volume.
60 meters per second at an angle of elevation of 30 degrees. Taking G, which is the acceleration due to gravity, be 10 meters per second squared. And let's have the sketch. The path projected from the level ground. And this is our projection. At an initial velocity of 60 meters per second. This is our initial velocity of projection. The angle of projection is 30 degrees. Given our G, the acceleration due to gravity as 10 meters per second squared. Ah. we have to find the time taken for the particle to reach its maximum height. And this is the maximum height attained by the particle. Concerning this topic, projectile, standard mathematics, mechanics, whereby this formula can be derived from the third equation of motion. From the third equation of motion, v squared equals u squared plus 2as, where a is our acceleration due to gravity. But in this case, our g is negative because the particle is moving against gravity. So the formula shall be v squared equals to u squared minus 2gs. But at maximum height, our final velocity will be 0. So v is 0. This is vy and uy. At maximum height, the velocity is 0. This is 0 squared. And u is allowed. This is our u. This is u sine theta. It is our uy. Then we squared it minus 2gh. Where AC is our maximum height attained. 2gh. Then we shall make h the subject of the formula. Making h the subject of the formula, we shall allow h to be our u squared sine squared theta sine squared theta over 2gh. This is the formula for finding the maximum height attained. Sorry? We are supposed to find the time taken for the maximum, to reach the maximum height. Time taken to reach the maximum height. But this formula will be helpful in part B of the number. Our part A, we have to find the time taken to reach the maximum height. And the formula for that is derived from the first equation of motion. We state that V equals to U plus AT, whereby A is acceleration due to gravity, and it is again it is upward, which means negative. Then V is VU minus GT. Whereby this is VY, UY, UY. Then at maximum height, our final velocity will be 0 because the particle is not moving anymore. Then 0 goes to U sine of theta minus GT. Then our T shall be U sine theta over G. And this is the formula for finding the time taken by the particle to reach its maximum height. Take that. Using that formula, we substitute in the values of U, theta, and G. to get our time, whereby t shall be, our u is 60 meters per second. Our u is 60 meters per second times sine of 60, sine of 30, I mean, 30 over g which is 10. Then we feed in the values in our calculator. This is 60 times sine of 30 divide by 10. Then it shall be 3 seconds. This is part A. A part of the question is that. So now we shall go to the B part of the question. As I told you that we shall use this equation to find our maximum height at 10. Let's feed in the values. H is sine of 30 squared divided by 2 times g, which is 10. Let's feed in the values in our calculator. 60 squared times sine of 30 squared, close our big bracket, divide by 2 times 10. Our maximum height at 10 shall be 45. And this is in meters. The C part of the question says we are to find the time of light. Dear candidates 2025. Under this topic, projectile, the time of flight is derived from the second equation of motion. Second equation of motion, y equals to ut minus half gt squared, whereby our small t is the time of flight. We replace it by capital T. And what is our range? And range is the time, is the distance moved by the projectile from the point of projection to the point where the projectile lands. But moving horizontally, our arrow will be 0, and this will be 0. Our u will be u sine is our u will be u cos of theta and basically you talk. So let's fit in. Let's fit in. Y is 0. Is y equals to r, which is equals to 0. This is 0. Our u is u cos of theta. Initial velocity is u cos theta minus half gt squared u cos of theta t, which is the time of flight, minus half gt squared. From here, we shall factorize, we shall pull out the common term, which is t, u cos of theta. Here we shall have half gt. Either t equals to 0 or u cos of theta minus half gt squared, gt equals to 0. But our t cannot be 0. The time of flight, time to move from the point of projection to the point where the projectile lands, which is up to here, cannot be 0. Then this t is not equal to 0. So I'll have u cos of theta equals to half gt squared. Gt, I think. Then making t the subject of the formula, we shall have 2u cos of theta over g. That is the formula for finding the time of flight. Okay. Put in the numerical values.
Mr. Kaziva, can you look at this working here? We are moving in the vertical direction.
Okay.
So the initial velocity there needs to be looked at.
Yes. Look at the your cos theta. That one should be sine. That one should be sine. Remember? Yes.
Okay, thank you.
Maybe let him explain to his
I
colleagues
forgot this would
why
be
it is
sine of
sine.
theta. Sine of theta. Sine of theta. This is 2u sine of theta.
Can you throw some light why it is sine, not cos?
You talk. Present you talk. This is the formula for finding the time of flight. Then we substitute in the numerical values. This is 2, and our u is 16 meters per second. Then sine of 30 degrees divided by g is 10. Then we fit in the values. Times sine of 30 or divided by g is 10. Then our time of flight will be 6 seconds. So always time of flight is equivalent to 2t, where this t is the time to reach the maximum height. And somewhere we got our t to be 3 seconds. So t is 2 small t with the capital T, which is the time of flight, is 2 small t. Our small t is 3. Then if we double it, we shall have 6 seconds, which is always true. Then the horizontal range of the particles is our D part of the question. And the range is derived from the second equation of motion. Y is against the x-axis is x equals to ux t minus half gt, and our t is the capital T, which is the time of flight. This is t squared. Our t is the capital T, which is the time of flight. If we are to demonstrate our range is the distance moved by the particle from the point of projection to the point where the projectile lands, and it is indicated as R. This is our range. Therefore, the time moved from the point of projection to the point where the projectile lands, it is the time of flight. So we substitute in the value. And horizontally, our G shall be 0, because the particle haven't moved any distance, haven't accelerated, and it has no displacement. So G will be 0. And X is the range. Our UX shall be U cos of theta. Therefore, we fit in these values, the second equation of motion, and we shall have X is R and UX is U cos of theta times T, which is the times of flight, minus half GT, half our G is 0. Then T is the time of flight squared. The whole of this shall disappear because of the 0. You can use the picture. This is the then R equals U cos. Okay. From somewhere, we got our T, which is the time of flight, as 2U sine of theta over G. Then we substitute in these values here, where there is T. This is theta cos of theta. This is 2U sine of theta over G. R will be is U 2 sine theta cos of theta all over G. But from trig, This is u cos of theta times 2. This is u squared. Then from trigonometry, paper 1, 2u sine theta cos of theta is the sine of 2 theta, and this is u squared sine of 2 theta from math paper 1. And this is the formula for range. So here we shall substitute we feed in the values of u, theta, and g. And our range shall be 60 squared times sine of theta, 2 theta. Our theta is 30 degrees. We'll divide by g is 10. Let's fit in the values. Our u is 60 squared times sine of 2 times theta is 60, sine of 60, divide by 10. Then our range shall be 3,110, 111, I mean, 0.7. 7691. This is in meters, the distance, then range. If we round up to 2 dPs, it will be 311.77 meters. This is our range. It's the last question.
Okay.
Any
Thank you.
question, please?
Any question? Dear participants, do we have some questions? Okay. Thank you so much. Parabek Secondary School, and that's where we okay, one person. Yes, Jovan? Jovan?
Use that.
Sorry, Jovan?
You talk.
Is there any question?
Oh, okay. I'm failing to.
Thank you very much. I think Parabekeses have so far come to the end of their presentation. So I would request if there is any question from the audience out there to give it out because of maybe time factor and other things. Any questions, members? Any submission or any correction somewhere there? It's highly appreciated as well.
Okay. I think there was one person, but I'm failing to get him, but everything is okay. Thank you so much for the presentation for our Beck Secondary School. Okay. Thank you. Okay. Yeah, students, when it comes to yes. So, dear students, when it comes to numbers mechanics, please make sure one, units are very important. Those units, in case it is distance, you know we shall always work with meters, depending on the question you are dealing with. In case now for such a case, for the particle, we expect that you write the right units, that your height is going to be in meters. My time is going to be in seconds. The time taken for the particle, it will be in seconds. The horizontal range will be in meters. So make sure that you write the units after obtaining your answer. Then for those particular values where you are getting decimal points, at least make sure you have at least 2 decimal places when it comes to your answer. Avoid rounding off to just 0 decimal place unless you have been told to do so. Then I'm seeing a hand from Sememe Girls. Sememe Girls, can you first unmute? Sememe Girls, unmute.
Ask. We are just asking for the question papers. The question paper of this discussion we have been having.
Okay. Okay, we are going to share it in the chat. Okay, then secondly, having a sketch is very important. If you have a sketch, please make your sketch such that you can have your work clear. Yes, sometimes depending on the number, those sketches you draw carry a mark. But when it comes to force diagrams and you have made a sketch, force diagrams where sketches are needed, we expect you that always take note that directions are important, show the force on the direction, but also look at when we are representing forces, we use the straight edges. So you'll check out last year's paper 2. You will notice that we had a question in section A, but many of the students, when they were drawing their force diagrams, they didn't have a straight edge. So for them, they were just drawing funny diagrams. So make sure that in case these forces, we expect you to have forces with straight edges. That is when it comes to those force diagrams. Then when it comes to these projectile numbers, it is okay for you to have a sketch, and let's have a well working sketch. Resolve, you can first have your forces resolved very well. Like you have seen that you have the particle, you have placed your 30, show the direction of the velocity. You can even resolve very well and then have such that you do not make a mistake. Remembering that when we are moving along the horizontal movement, if this is our velocity, let me say this is our u, and this is where we have our angle. You know very well that when I'm getting the horizontal component of this particular one, like this is where you have x, you'll notice that when you resolve this particle towards this horizontal axis, we shall have our velocity as u cos of theta. When I resolve this particle along the vertical, I'll have it as u sine of theta. So when you are dealing with vertical motion of this particle, we shall expect to use u sine theta. Anything horizontally, it will be u cos theta. But also do not forget that since this particle is going up, it is opposing the gravitation law. So we expect that your g, in your formulas that you write, you'll have negative g, because it is opposing the acceleration due to gravity. Then last year still, one of the things that happened that many students do not want to follow instructions. Many of you want to do your own thing, sometimes the way you have crammed them. A case in point, many of the physics students like using 9.81 without reading the question. So many students failed to get maximum scores because they crammed or because they had it already in their head that acceleration due to gravity is 9.81, and some of those figures that we usually cram. Always follow the instructions that the question has given you. A case in point was this question. Like you have noticed, some of you have been saying acceleration due to gravity is what? 9.81 meters per second squared, but yet the question had given us 10. So please always first look at the question, follow the instructions, and do what the question wants, but not what you want as a person. So make sure you go on and follow the instructions. However, we may not be able to finish all the questions today. Tomorrow is another day we can have some of these questions still discussed. So tomorrow we are going to come back here at 2 p.m. mostly to cater for our Seventh-day Adventists that have not been able to complete. But I know also some of you may wish to come back such that we complete these questions. So tomorrow we shall come back here to discuss other questions. Mostly we shall concentrate on the questions that have not yet been discussed today. But also next week, we are starting a program. This is to support you again, because when you look at the statistics for last year, you might have noticed that the performance of mathematics was very, very poor in both papers. So we are going to have another facilitation for all the subjects you do in your schools. So starting next week, we are going to be running for 2 weeks. And this is to inform all the schools that have joined and all the students that starting next week, we are going to have 2 consecutive weeks of facilitation. We shall have now next week, Monday. However, our facilitations, they will be starting at 4 to 6 p.m. every single day, such that you are very ready for your mock examinations, but also for your NAEP. So in case you see any subject that you are doing on the timetable, so you prepare early enough such that you may not miss out on this discussion that we shall be holding next week. I know you may not be able to see math here, but since we have had math today, that's why we shall bring math again the other week. So the other week we shall have chemistry, we shall have biology, physics, and other subjects, but we shall cater for the biggest percentage of all the subjects that you do. For the schools that have not been able to present, do not worry. We still have tomorrow. Notify us early enough that you want to make some presentation tomorrow. But also we do request that whenever we put out a link for you to register, to book a question, you do so, because it helps us to plan better such that you can be able to present. At this point, I want to thank all the schools that have been online and all the teachers that have brought in their children, and allow me to invite Mr. Ronald Dungu to give us his remarks and to officially close this session. Mr. Ronald, you are most welcome. I don't know whether let me first check whether he's on. Okay, unfortunately, he has dropped off. But just to confirm. Okay, yes, but like I've told you, starting next week, we shall have what? Those sessions. Yes, so let's meet tomorrow at 2. But I'm also requesting schools that have been here and maybe you have not filled in our form, the registration form, kindly fill it in such that we can plan better for the coming seminar. But also I'm going. Okay, I think he's not going to come back, but we shall have all those questions discussed tomorrow. So tomorrow join in early and then we can have those questions discussed. We want to thank you for everything. Thank you so much for joining. But maybe before we go, allow me to first share my screen. Dear students, I do understand that not all of us are doing well when it comes to math. I know some of us are still struggling here and there. Things are not adding up as we do expect. The marks we have been obtaining, they may not be the best, but I know also we have those that are really doing very, very well, where things are really adding up. You are getting the 90s the way you wish. You are making it. But I'm going to request you that as now we prepare for these mock exams, kindly have some sections that you are really very sure that you can do. I know there are some topics you have read and things really are not adding up. You are doing all the best. You have put in the efforts, but things may not be working out. I want you to look at the different sections like I showed you early in the morning, that you have these 5 sections, let me say for pure 1. Look out for that particular one and say that if anything comes in algebra, I'll have those marks, section A and section B. Section A, these are 10 marks. These are 24 marks. But I know sometimes we may not get all the marks. Section B, in fact, when you look at 10 and 24, that is around 34 already. Go and say analysis. At least let me get one number and let me at least get 10 marks here for one number. When you look at these marks here, I want to assure you, you have already gone beyond a pass 7. That is above a pass 7. When you check out, you have already obtained a pass 7. This is around 49. Just add on just one number. Just add on 2 marks and maybe 2 marks. You'll be very good to go. For those who are really struggling. Then for schools or for those students who are not doing anything when it comes to paper 2, I know the teachers may not have been able to cover everything. In case in paper 2, you are doing your best, but you feel mechanics, things are really not adding up. Then make sure you focus very well. Have numerical analysis and probability passed well, such that you know that if you pass those numbers, you are good to go. That if I pass the 5 numbers, this one I can get 25 marks. But in case I know sometimes things may not go on, you may get your 20 in section A. Come in section B, make sure at least you have 4 questions passed very well, such that you have a 48. So when you have 48 plus 25, surely that would be 73. You just need some few things to make things work. So make sure that you strategize. And remember, when we talk about success, I think, let me hope this is success. Number 1, S stands for sacrifice. I've generated this myself. So S will stand for the sacrifice. That there are certain things at this point in life you need to sacrifice. It can be, you need to give up on them as for you to be able to achieve certain things. So you need to sacrifice. It can be your phone. It can be those things that you feel are taking a lot of your time. Sacrifice now such that you can be able to enjoy at a later time. Number 2, understand your purpose in life. Understand the reason why you are at school. This is understanding. Understand your purpose. Why am I at school and why am I taking on this subject? When you understand the purpose for the subject you are offering, then it will be very easy for you to put in all the necessary efforts to be able to pass. Then number 3, this one will stand for consistency. You show up on a daily basis. Sometimes the teachers are doing all they can within their means to support you, but sometimes you are not consistent. In case it comes to math requires consistency. If you have done a number today, do another one tomorrow. Keep on doing daily. Show up daily, no matter what is happening in your life. Show up. Number 3, be committed. This is being committed. Be committed to your goals. You set out goals and say, I want to achieve this. Surely you'll achieve it as long as you are committed to what you are doing. Number 5 is effort. Put in the effort. Someone who puts in effort is better than someone who has the talent. And you can beat anyone with a talent as long as you put in the effort. Put in the effort in whatever you are doing now, surely success will follow you. Then S stands for the strategy. Strategize very well. Look at the papers. Approach your teachers that are teaching you. By now, I know they know your weaknesses. They know the areas that they can support you in. Strategize and say, when I'm doing applied math, these are the numbers that I want first do before I jump into other numbers. In case I'm handling pure math, this is what I need to do. Lay a good strategy. And then the last one is what we call self-discipline. Self-discipline is doing something. Self-discipline is that personal push that you'll have. Self-discipline means that you even when you feel you are maybe tired, you even go on and show up. Those things you do when you do not want, So make sure you have self-discipline as a person. When you tell yourself that today, you know what, I am going to read math, you go and read math. Make sure you go and read math. Self-discipline means ability to police yourself. Do not read because you have seen the teacher coming. Do not read because your friends have told you. So that ability to control your behavior, actions, such that you can be able to achieve your goal and maintain different standards. So self-discipline is key. And for any child that will make it in life, discipline is key. Make sure you are very disciplined. Make sure that you do all it takes. Do not wait for the police. Do not wait for the matron to wake you up. You wake up yourself. Do not wait for the teachers to tell you, keep quiet, keep quiet. Please make sure you do it yourself. Have that self-discipline. I'm going to ask whether we have any teacher who wants to add something or to give a package to the students before Mr. Ronald closes off the session. Any teacher on the call who wants to talk to the students, to give them some package. Okay. So allow me to welcome Mr. Ronald to give us his closing remarks and to officially close the session. Mr. Ronald, you are welcome.
Thank you, Mr. Kaziba, for the time you've given us today. I had asked the teachers in the chat to send you a message so that you can add them to the WhatsApp group if they are not there. Maybe you type your WhatsApp number in the chat. And also, I don't know if you talked about the facilitation lessons that are starting next week.
You can add your voice, Mr. Ronald.
Yes, for the next 2 weeks, we shall be concentrating on supporting the candidates, Senior 4, Senior 6, and we'll be having teacher-led sessions in different subjects, and there is a timetable we have put out, and I hope your schools will also join in. But also tomorrow at 2 p.m., Mr. Kaziba, I hope you've confirmed, this session will continue so that we have those who have not presented, plus our brothers and sisters from the SDA Church joining us to also learn something. Dear students, our wish is that we all excel together. So we are struggling to ensure that all of us can work together and excel together as a team. And we will do whatever it takes to continue these sessions to ensure that we support you until when you sit your exams. I want to wish you all a good weekend. I know it has been a long day today, but it is the effort that you put in that will bring the results that we want. With those few remarks, I want to declare today's session closed until we meet tomorrow at 2 p.m. Thank you.